Hi, Tim. Very good morning and good evening, all. So let's get started, guys. Okay. So as it's so far, what we have seen in the yesterday's session, right? It's all about the object-oriented programming we started. That is the last part of our Python learning. In that object-oriented programming, the predominant thing, the fundamental thing, what we are supposed to know is all about the classes and objects, right? So the functions or the methods what we are creating inside the modules can be further kept down in the classes, and it can be instantiated in the form of an object to get accessed. Right, the functions whatever we wanted to maybe like apply or wanted to achieve, the functionalities whatever we wanted to achieve, we'll be not directly creating inside the module. Right, in the hierarchy of program, we were creating the functions inside the classes and grouping the functions in a class, and whatever the classes are needed in the respective or whatever the functions are needed in the respective class, we will only bring them and instantiate them in a form of an object. While we instantiate the class in the form of an object, using some concept called the parameterized constructor concept, what we do, we will instantiate the class by passing some parameters, right? So while the program is getting loaded, it will load with some values in the attributes what we have defined inside the class using some init function and all. When the class is loaded in the memory, the init function, the initialization function will run and load some attributes for the class, allow us to pass some attributes for the class to consume that class with more modularity or more better functionality. For example, yesterday by the near ending of the session or almost after the end of the session, somebody was asking about the same, like how altogether if we wanted to work on a particular program, how it works. I was talking about this example. You are having a call center running for a telecom company. The agents are sitting in the call center and the technicians who are all going to fix some products in the customer premise, right, will be calling the call center agent to understand how much charge they have to incur for the customer premise, for the customer where he installs some product. So what happens in the agent one means the call center agent one will have the telephone class instantiated in the memory by creating an object. The agent one will create an object of rotary installation, touchstone installation, and the router installation. Kind of three kind of objects he will create. Three objects he will create by loading the same class in memory with three different arguments passed. Saying like, for rotary phone, right, the charge or cost per hour of installation is $10. And for the touchstone phone, the cost we are going to incur to the customer is $5 per hour, not $10 for touchstone phone. For routers, Wi-Fi router, we are going to charge only $3 per hour for the installation cost from the customer. So based on the agent or the technician who informed the agent saying like, hey, I have worked for around 6 hours to fix this particular rotary telephone. Like this, if we call and inform the call center agent, the call center agent will go and invoke this installation cost function, right, by passing 6 as an argument. So already what he did is he created an object in the name of agent one, rotary installation cost or something he created as an object. So object dot function name he will call. So inside this class, we have a function called installation function, installation cost. So this class is loaded in the memory by passing some arguments of model and the cost per hour. For the rotary phone model, $10 is the cost per hour. So what this call center agent will do, he'll go and call the function called installation cost function by passing 6 as an argument, what was been told by the technician, saying like, hey, 6 hours I took for installing this particular product, the rotary telephone product for the customer. Like this, when he say, he'll go and pass 6 as an argument to this function, and 6 hours into self dot cost per hour. Self represents what? This class dot how much cost per hour has been set by the company. Company have told, hey, for rotary phone, we have to charge $10. So what happens? 6 into $10 will be returned, which is nothing but $60 we have to charge to the customer for the particular product of rotary telephone installation for 6 hours. Like this. This is a kind of a standalone application, right? You can consider this as an example of, we see it in the real life, right? So we might have purchased routers or phones at our home. the company, telecom company's technician used to visit our home and he will install all the routers and everything, right? Sometimes the company will give for free of cost the router and installation also free. Sometimes they'll be charging you, depends upon the company's offers and all what they're offering. So let's assume they are going to charge us for installation, right? Router may be free, let's assume in that way. So what we do, the call center agent or whoever is going to build this product will be having this kind of class created by the organization and kept ready. Maybe for this current month or this current year, we are charging this much amount for the respective types of phones. For the routers or touchtone phone or rotary phones and all, we are charging the amount accordingly like this. So what they will do, the agent, the call center agent will have 3 objects created, 3 objects of this class created with each and every object with different product information. So he will instantiate this class attribute or the instance attribute we used to call it as, right? The members of the class, the variables that we instantiate at the time of runtime, at the time when the class is loaded in the memory, this guy will load this class in the memory along with this values defined to this variable. So these are all the class attributes. These are all the member variables of the class, not directly, indirectly, because we use init function. When the class is instantiated, this init function will be called. Then the init function will go and set model as so and so model, and the cost per hour is $10 per hour for the model of what? Rotary phone model. For the model of touchtone, $5 will be charged. For the model of router, $3 will be charged. Like this, 3 objects are created by either a same agent or a different agent, depends upon the type of what to say, like product. Different call center agent may be called. So different agent may instantiate this class in the form of an object. Or in the application, what I'm going to work, the agents are going to open some application for the billing application to charge the customer. In the application, whatever the agent have opened, that application might be having these 3 objects got created, loaded in the memory, and this class got instantiated in the memory in the form of an object like this. So what that application will do, when the agent pass how many hours it took for installing this product for the particular product of rotary phone, the cost will be returned back by the application saying, hey, you have to charge $60 from the customer. You have to charge 4 into $5 from the customer. That means $20 from the customer for installing touchtone phone. So you have to cost 3 into $10, $30 from the customer. Like this, the application will return the result to me. Be it an application, it's not a manual call we are doing. These all will be done by the application in the background. We use some front-end application and all, right? So this is how the things will work in the real-time case, where we use a class with init function, with self keyword, with member functions, with maybe like parameterized constructor, and all the concept what we discussed yesterday. I gave you some simple program where I wanted you to fill with all those concepts, right? I hope you guys were getting some time for filling that, right? To ensure you guys were able to catch what we are discussing, right? So by doing this operation, you can say, maybe let it be. I just gave you this example, right? Yesterday. I wanted you guys to, this company example that I have given yesterday, I wanted you to fill with what is what, right? What is this class? What is this company? What is this init? What is this what is the self keyword used for, right? And what is this function we call it as? What is this variable we call it as, right? All the things. Maybe which program I have shared you guys. 1 second, I'll check. The company only, right? The company, we had some local variable also can be defined. Without self keyword, if I define, it's a local variable. With self keyword, if I define, this init function says I instantiate a variable or a member variable or an attribute to the class, not for me. I'll instantiate and give it to the class. So this variable is not belonging to me. The init function will say, this is not my local variable. This is the variable which is going to be a member of the class. I help instantiating this variable by passing an argument, by getting some argument passed by the customer, right? When at the time of loading the class in the memory, I'll allow the customer to pass some argument, some parameters to this class in the form of an init function, right? Like this we were having. So Piyush have updated this program with some examples, it seems. So this is the program I have shared, right? Which program? Company. Okay. So Piyush have put all this in a form of some comments. Okay, let me put all of them in a comment what Piyush have provided. Class, keyword to define a class. Excellent. Company, class name with init uppercase. The class name should be of init upper. Otherwise, if you give a small class name, it will accept, but it will say what? Hey, class name should use camel case convention. Use init uppercase. Use camel case. Don't use a normal case. Like this, the program itself is suggesting us. Def keyword is used to define a function. Init is a special function. Yeah, special implicit function. Right? This is not a normal function. This is an implicit function. To instantiate, to initialize instance variables. Right? It helps to create parameterized constructor. Excellent. Right? Whenever the class is instantiated, the init function will be called. Right? Special initialize instance variable called when class is instantiated. Class is instantiated means what? When we put bracket, open and close bracket in a class, it will become an instance of the class. At the time, this init function will be called. At the time, we can pass parameters if you want. That is what it says, right? Self says what? By default, functions inside the class accept first arguments as self. Yes, by default. Very important. By default, it is like that. But we can change the default thing. But by default, it works in that way. The object of the class will be passed in the self parameter. Excellent. Excellent. This is very, very important point. Good, Piyush. Right. So this self keyword will be used for passing the instance of this class. If I don't pass the instance of this class, I have to mention the class name here. It works, but it is costly. We don't follow in that methodology. I can directly mention, hey, rather than passing the self, you pass the class name. Right? Use the class name rather than self. I can mention like that also. It works. But this is a costly effort because every time when I go and mention class name dot attribute name, it will go and maybe like do what? It will go and instantiate the class in the background by using the default constructor. So that is a costly effort. No one will follow that. But just for your information, this self is nothing but the class we are referring to. The class means the instance of the class we are referring to. The class that is loaded in the memory, right? That one we are referring to. So that is the self keyword what we are using in a simple terminology. It is not a mandatory name we have to use. You can use any name, but self is a preferred name by the program itself, right? And then object.jan, object.feb is nothing but the different instances or objects of the class. Excellent. Excellent. The different instances or objects of the class, right, can be created by passing the respective parameters, right? Parameterized constructor. So company of 5000 is a constructor which accepts one argument as bonus, right? It's a parameterized constructor. Parameterized constructor. So however, whatever you mentioned as a constructor is correct. Of when I give, bracket when I give, the bracket represents it's a constructor. Construct this program in the memory, like this I'm telling. By putting a bracket on top of the class, I'm telling construct this program class in the memory. Load this program in the memory. Right? Accepts an argument. Because I used init function inside the class. So by that way, I can able to accept one argument. Init function with parameterized constructor. Very simply say, this company will accept an argument. Basically, class will not accept an argument. The class will get instantiated in the memory, but I am telling what? Hey, using the init function, I want to pass some argument called 5000 or whatever to set as a class attribute. Like this, I'm passing an argument. Then the salcalc is a function, regular function, method or a function, whatever you name you can give for that. right? Inside the class, we call it as a method. In general, if we create, we call it as a function. Like whatever we created over here is a function, or whatever the function that we created inside the class, we call it as a method. Or even in everything you can call it as a function, or everything you can call it as a method also, doesn't matter. People use interchangeably this word. Both are same. Methods or functions, both are same. Okay, is called using the object name dot function name, passing some argument. So already this object is instantiated with the bonus set as whatever the amount 5,000, and the salary now I'm going to pass to this function, the salary function for every employees. So it is going to be set with 10,000 plus bonus of 5,000. Bonus is coming from the class attribute, coming from the maybe like the member variable of the class, which is set using the init function. And the salary is passed in the runtime. For every employee, I'm going to call the salary function to get the salary and the bonus applied and get the value returned to me. Like this, rather than calling this function directly, we are creating a class. We are setting some argument, or we are setting some instantiation values for the class. At the time when the class is loaded in the memory, I want to set some values additionally to the class, which can be used by the function, right? So what I'm doing is, rather than creating the function directly, I'm keeping them inside a class like this. Rather than creating a function directly that we did so far, I'm keeping them inside a class. Then what I'm doing, I'm not loading this class in the memory to create an object just like that. I'm just creating some, or I'm passing some parameters to this class via the init function. Init function is helping us set a variable, which is a class variable, which is a variable of the class, and it is transferring the rights to the class by saying self dot bonus 1. By that way, this variable is becoming a member of this class, member variable of the class. In that member variable, I'm setting some value at the runtime, bonus value at the runtime, by passing this 5,000 as an argument. So there is a class variable I have called bonus 1. We call it as an attribute or variable, class attribute or instance attribute. Anything you can call it as, doesn't matter. You call it as an instance attribute, you see here. If I create an attribute directly, this we call it as a class attribute. This we call it as an instance attribute. Terminologies may vary. Functionality remains same. Okay. Terminology may vary. That means what? When this class is defined, I want to access an attribute of the class, which is using what type of parameter, what type of constructor here. So if I have bonus 1 equal to 1,000, it is telling what? This is a class attribute. At the time when I instantiate this class, this bonus 2 will be loaded in the memory, right? Automatically, without having an init function. Whereas this bonus is telling what? I will be instantiated at the runtime with the help of an init function, and you can set some variable for me, value for me at the runtime. Here it is hard-coded. You can't be able to pass an argument here. Here we can't pass any argument. Here we have to only set it as a static value. So this is otherwise called as what type of constructor? Default constructor. When I don't mention an init function, automatically this variable will be kept inside the init function. I don't have to do that. But if I keep some variable inside an init function, what is the benefit I get is, even we can pass parameters. We have an option to pass it as a parameter. If we don't have an init function, the parameters can't be passed. The parameters constructor can't be created. Either you go with the default constructor or you go with the parameters constructor, non-parameters constructor, both are almost same. Right? So let's not worry about that. So there are options we have available. Mostly we use init function. In any of the classes you see, the immediate function, the immediate line of code after the class definition is init function. We basically write. Either we pass an argument or we hard code, doesn't matter. I'm not going to pass an argument here. I'm going to hard code. Even we can do it in that way. But what is the drawback you have? For January also, the bonus will be set as 5,000. For February also, the bonus will be set as 5,000 across the class. That I don't want to do. I want to pass it as an argument every time, based on the need, based on the type of the service that I'm doing, based on the type of the maybe device that I'm installing to the customer, I want to charge per hour differently. So every product has their different charges. So I'm going to create a parameterized constructor here to say for this model, the cost per hour is this much. For a model of rotary phone, the cost per hour is $10. Like this, I'm going to instantiate this class with some attributes defined at the runtime. Instance attributes of the class. When this class is instantiated, I'm going to instantiate certain attributes by passing some arguments to this class. We use what type of methodology here? The parameterized constructor functionality here. I'm passing some parameters while I'm constructing this class in the memory. Parameterized constructor. So this variable can be used inside the other member functions by using the self keyword. That says what? Hey, this model says I am a instance variable of this class. I get instantiated at the time this class is instantiated. So you can use the class name dot this particular variable name to access what is the cost per hour for installing a particular product. So cost per hour for installing the rotary telephone is $10, and how much hours it is took for installing for a particular customer, the particular touchstone or rotary phone, 6 hours it took or 4 hours it took. So I'm going to charge this particular customer 4 hours into $10 per hour. So the same function I'm calling right inside the same class, but for a different models. So I will instantiate this class as rotary object, touchstone object, or whatever the object that I'm creating. According to that, I'll be setting the cost per hour. Based on the cost per hour, how long the time taken for installation, right? Based on that, I'll be charging. So I may take the same 4 hours for installing router, but the router cost per hour I'm setting is $3 only. So $12 only I'm going to charge from the customer, not $40. $40 for rotary phone. How can I control that? By having a parameterized constructor defined, I can say, hey, for rotary telephone, we are going to charge you $10. For maybe like router, we are going to charge you only $3 per hour of installation. So the same time taken for not rotary object for maybe like what to say, the Wi-Fi router object means that is going to charge you only $4 into. Internally, I'll create an object called router object with $3 per hour installation cost. So $4 into $3, $12 only we are going to charge you. Like this, we'll inform the customer by the way of having the parameterized constructor. So this is minimum what you are supposed to know. How many of you were able to create this of your own? Tell me, guys. How many of you guys are creating this of your own? Maybe in whatever the way you created, doesn't matter, right? Maybe make use of this, what we discussed. I just altered a bit, very minimally, right? So in whatever the way you created, right? All I need is how much of you guys have tried. Whatever you tried, whether it is right or wrong, that is a different story. But when you try, you might have put some effort of understanding, right? So Singaraj have tried in some other way, it seems, right? Anything is fine, okay? Right, template or a blueprint program instantiated at the runtime, right? Init function, initialize the function, allow the variables or attributes of the functions to be defined or to be instantiated at the time when the class is instantiated. Self like an initial reference to the class. Fine, whatever you mentioned is correct. OBJ1 is an object instance, right? The member variables will get loaded in the memory area along with the class. Along with the class program, along with the class, the member variable will also be loaded. Excellent. Whatever you're given, good, Singaraj, right? So hopefully most of you guys have tried, right? Who did not try, ensure to try this of your own as well after we had this many round of discussion, right? Why I'm discussing about this one alone by spending this much time, right? Why I'm spending this one alone by spending this much time is to ensure you guys are all having some understanding out of it, right? Minimum understanding. Rest of all, what you are going to learn now by spending some time, not much needed, right? You have to know once for all, right? To understand, oh, this is the concept implemented in the background, right? Rest of all, what you guys are going to learn, now we are going to start learning, is not much important as like what we have seen these items, right? So you can consider these are all the important items, what we have seen till here. Important items are completed. Good to know. Items are started in our learning. Okay. Let's see how, which are a bit good to know, but important to know. Minimum all this, right? Must know. Minimum we are supposed to know. What we are supposed to know, right? Minimum refer this below code to understand the fundamentals of object-oriented programming, right? Whatever the name you give, I don't bother, right? Important stuffs to understand and know. I gave it in different perspective. What all I wanted you to know is only this one. Can you all say I understood this one completely? Leave that name, parameters, constructor, the terminology, whatever I used. The instance attribute, class attribute, or whatever you forget. Just to see this is a class, this is an instantiation function. Automatically, we have to create this function. Whether you're passing an argument or not, that is a different story. The member method I'm creating, right? And then I'm creating an instance of the class or an object for the class by instantiating the class by using the constructor. The open and close bracket, when I mention, I'm creating a constructor. By passing a parameter, so I'm calling it as a parameterized constructor. So I can access the members of the class by using this constructor, using this object. Object help us access the members of the class. Object help us load the class in the memory. This is what you have to know by looking into this program. This is the only program what you are supposed to consider. Maybe a different aspect of this program, if you want to see, go and see this image, try to understand. In real time, how do we use? I just shown this example, try this as well. Okay, fine team. Let's go forward to the next level, right? So we discussed about what yesterday, what is a class, object, member functions, member variables, init functions, self keyword, all this what we discussed. Something related to the parameters, non-parameters, and default constructor. Only the 7 concepts we learned yesterday, and I hope you guys are all good in that, what we learned so far, right? So where is it? I just put all this over here, right? So to understand about these concepts, constructor, init, all this. Constructor, init keyword, default constructor, all this we learned. Separately we learned. First we learned about what is this? We were able to learn. Then we were learning about what is constructor and init function. All we learned yesterday. Now I'm going to take you guys to the next part, which is good to know, which is not must has to be known, but good to know, which is nothing but detailed object-oriented programming concepts or fundamentals. I know definitely you might have heard about these terminologies. Tell me the terminologies what you guys heard about in the object-oriented programming. In general, you might have heard about all these terminologies. When somebody says object-oriented programming, you might have heard about all these terminologies, right? In the school days or college days, or even in your organization, or in the C++ book, right? And anybody who learns some programming language, especially if it is an object-oriented programming, especially if it is C++ or Java or .NET, or somebody learned this object-oriented programming, you might have heard about these terminologies, right? Excellent. So inheritance. I could say detailed object-oriented fundamentals are features. Features. These are all the features. Benefits. Why we go for classes and objects, right? Directly we can create methods like this, functions like this. Why we have to go with classes and objects is the question here. Because we can leverage all these features of object-oriented programming based on the need. Inheritance, excellent. Polymorphism, right? Abstraction. Anybody mentioned abstraction? Okay, yes, Ram. Abstraction. Okay. Encapsulation. In the polymorphism, we have two concepts like how you guys have mentioned. Something called overloading, overriding. That's it, guys. These four concepts, if you know what I have shown here, well and good. Maybe you can add something more on top of it, but this is well and good to know. Minimum. When it will be useful? What is the use of learning this? Why we have to learn this? Know this? Yes, excellent. To develop an application or understand an application, a pre-developed or a developed application, or a framework, or to teach your kids. All these are the reasons. Okay, if I'm going to open an application or a framework like Spark, which was developed by somebody, I have to know how that is being developed, right? Or if I'm going to use some functionality, I use with awareness. For example, I'll tell you some examples, okay? So to develop an application or to understand the developed application or framework, right? With better understanding, with better awareness. Let me tell you an example, okay? What we'll discuss, but before that, we know I have a list of values created, okay? Or I have list of values in my hand. I have string value kept in my hand. I'm going to use a len function to calculate the list of values. I'm going to use the len function to calculate the length of the string. So how many elements I have in the list? Maybe let me put this list as inceptez itself, like this. Like this we have, right? So what is the difference between this len function that is applied on top of the list type and the string type? Tell me, guys. What is the difference between these two? The list is helping us, or the length is helping us finding the number of elements in the list, right? Or we keep it in a different way. Rather than keeping like this, I'll keep it in a very simple way. The same inceptez I'm keeping inside the list, okay? What is the length it is returning? But whereas here, when I go and calculate the length of the string, it is returning 8. The length of the list, it is returning 1. What is the difference it is making? When I pass a list as an argument to this len function, it is returning the number of elements in the list. The number of element is only 1. If I pass the same len function with the string, it is returning the length of the number of characters. This property we call it as what? The function with same name, but different in type of argument that we are passing. The type of arguments that we are passing to a function is different. We call it as what concept? Overloading concept. Excellent, Lavanya. We call it as a overloading concept. But we use this function Did we use the same function earlier? We passed list as an argument to a function and string as an argument to the function. We know how to use this. If I give you guys this string to you and ask you to calculate the number of characters in this string, what you do, you put a len function, the string variable you pass as an argument, you get the result saying like, hey, there are 8 characters are there in this particular string, Irfan, like this you will say. Do you agree? But when I ask guys, what type of function is this if I ask you? Or what type of concept of object-oriented programming we are using here if I ask you, you'll say what? I don't know what methodology we are using and all, or what feature of the object-oriented programming we are using, I don't know. But we can use this function to calculate the length of a string. Can we use the same function to calculate the length of the list? If I ask, you say yes, it is possible. Then I'll ask a question, guys. The same function can take 2 different types of argument. The same function is taking the string as an argument or a list as an argument, but it still calculates the result and give me the result. How that is possible? Like this, I'm asking you as a question. Because of the len function is a polymorphic function. The len function uses a concept of overloading in the polymorphic feature of object-oriented programming. You will be having a better clarity. After we understand this object-oriented programming, you will say, oh, because of this feature, what object-oriented programming concept provides, Python is using that feature to make me use the same function to get the result differently for the different input arguments that I pass. Following me what I'm speaking? What I'm speaking is very direct thing. If you know object-oriented programming concepts, you can use the functions or methods or whatever the features of or whatever the code base that has been developed by somebody more efficiently. This code is developed by somebody, not by us. But we are using this code in a more meaningful way, more in an awareness way. We are aware of what we are doing. We just don't say, hey, the len function can calculate the length of the string, the number of elements in the list, it can calculate. Like this we can say very well. But what methodology it uses to calculate? What feature of the object-oriented programming this len function is using, we don't know. I don't want it to go in that way. I want to say we are aware of what is used in the background. Whether we are going to create this len function or not is a different story. But what it is using, minimum we have to know. Clear? Okay. Let me go back to that part of discussion. Okay. So we have concept like inheritance, polymorphism. In the order of importance, I can mention. Okay. Maybe the abstraction and encapsulation come together, maybe having almost the equal priority. Or I could say encapsulation has a better priority than abstraction. I can put in this order. Okay. Encapsulation is more important than the abstraction. Abstraction very rarely used, but encapsulation used mostly in the applications. But leaving these 2 concepts, the primary concept of inheritance and polymorphism is important to know. Not much important, good to know all these items, the detailed object-oriented programming, but still, if you want to give some priority in learning of these items even, which is good to know only, not must to know, but if you are going to put some importance, you can put importance for inheritance and polymorphism. Inheritance must be known by everybody. Whoever says, I know, oops. Okay. These are all the features that we are going to discuss. Inheritance, polymorphism, which comprised of overloading and overriding. Abstraction, encapsulation. If you know about these concepts, you can say, I know the concept of object-oriented programming. Inheritance, right? Okay. I don't know oops concept, but I have a question. With this, overloading will be applicable to specific function like len, or it can be used any of the regular functions that will be created by us. That is what we are going to learn now, Visagan. Since you don't know the oops concept, I'm going to teach you oops concept now. You will be getting the answer for this question, what you are asking, by around 12 o'clock. Are you with me, Visagan? That is a matter of patience. If you are being patient, means you are going to get this understood. Understanding is very important. I'm not teaching you what is overloading. I'm telling you guys, there is a concept called overloading is in the behind scene. We don't know that concept is applicable. Only Lavanya knows or few among this set of people knows about the object-oriented programming, they're answering. Even they're hesitating to answer. Why? The reason behind? I mean, like that concept I am going to bring now in another few minutes, right? So Lavanya just told it is a overloading, and I told yes, Lavanya, good, you already know about it. But that is the one I'm going to teach. But what I am showing here is I'm not teaching about what is this len function. How this len function is created, I'm not talking about that right now, but we are going to see creating some overloaded function. That is a concept, okay? Stay behind and listen. You are going to get that, okay? Wait for it. Yeah, so she remembered from her academics. So that is what I was just trying to say. In our school days, college days, we might have learned about it, but not with a clarity. Now, we learned a lot of things so far, and with that, we are going to learn this very easily without putting a huge effort. Okay, that is what I want to convey. So wait for it. Just wait for it. Definitely, you are going to get an answer for what you are asking. Okay, and you are going to answer me. In fact, I'm not going to answer this question, what you asked me. Irfan, can I create a function with overloading concept applied? Overloading comprised of two concepts. One concept only we discussed. One more concept also we have. Wait for it, we'll discuss, okay? So before going to overloading, first we cover the important concept, the primary concept called inheritance. Okay. What is inheritance in English terminology, guys? In general, inheritance is an English terminology. Everything is English terminology. All are English terminology. Let's first to go with the English terminology of what is what. Inheritance means what? Excellent. Inherited property will be always, we remember, getting some property from the ancestor. That is what we always remember. To reuse, to reduce the time of writing the code, to reuse the existing feature rather than recreating it. That is a very important factor of inheritance. I'm inheriting this property from my parents. I'm inheriting this property from my friend, right? This characteristics from my friend. Rather than I develop these characteristics, I'm inheriting it from my parents or from my friends or from anybody else in this world. Daily, I'm inheriting some property from somebody, right? That is inheritance. So inheritance is nothing but incurring or inheriting or incurring some of the properties from the parent program or parent class. If a class inherit the property from some other parent class, we call it as an inheritance. So inheritance is a property of inheritance is a process of inheriting the features or characteristics, properties or members of a parent class. The literal example is a son inherits, son or a daughter inherits the property from his parent or parents. Parent means from his father or mother, from both of them, or from his grandfather. Anything can be possible. So by that way, we have different types of inheritance. If I incur the property from my father alone, then it is called as a single inheritance. If I'm going to inherit the property from my father and the mother, both of them, if I'm going to inherit, I'll call it as a multiple inheritance. If I'm going to inherit the property from my grandfather, my father inherits, then from my father, I'm going to inherit. It is nothing but a multi-level inheritance or hierarchical inheritance, like lot of concepts we have available. Or only from a father, the daughter and the son is going to inherit. That is one type of inheritance. Like we have different hierarchical or whatever the inheritance. I'm not very much specific about the type that we are going to see, but inheritance we can do some property. Property means I'm talking about the physical property or money. These are all the members of the father, mother, or my grandfather, or my parents. These are all the members, right? I'm having some members in my home, which could be the money, or which could be some property, which could be some property documents or anything. If I'm going to inherit that, rather than I'm putting an effort of earning it, I'm not going to put an effort of whatever my father put for decades to earn some property. I'm not going to put the same effort. I'm going to just inherit from him, right? Rather than developing it again from scratch. That is the property of inheritance. With the way, if you create a program in a form of a class, we can inherit the class in all the way. Rather than we develop the class once again, we inherit the class. That is the concept of inheritance. Okay, what is a simple example of inheritance? Let's try to learn, right? What are all the characteristics of inheritance? We can see here in this document. I don't want to put a lot of content over there in the program. You can see this. Inheritance is a process of inheriting the features in a form of members or member variables or member functions or other classes that is defined inside of the class, or anything from a parent class. Some functionality, some features, some members from the parent class. There are different types of inheritance available in every object-oriented programming language. Some programming language supports some of the inheritance directly or indirectly. That is a different story. Okay, what and all I mentioned here, we will discuss about it by understanding it directly by doing it, rather than understanding theoretically. You can make use of this for theoretical understanding. Okay. Multiple inheritance, one of the important concept we may use regularly. If one class can derive or incur the property from more than one superclass, this is a multiple inheritance. I'm going to inherit from two different classes. The class is going to derive the property from two different classes. Okay, we'll discuss about it. Key advantages of object-oriented programming comparing to the procedural-oriented programming. The function-based programming, what we are doing in Python, is nothing but a procedural-oriented programming. For Python supports even POP programming also. Rather than OOP programming, it supports POP programming also. What is POP programming? It's a procedural language programming. Like Oracle PL/SQL is a procedural language. It does not support the inheritance, polymorphism, abstraction, overloading, overriding, all these concepts. Oracle PL/SQL programming language will not support. Python supports both procedural language or object-oriented language, both methodologies. If I go with procedural language directly by creating the functions here like this, I could not be able to achieve some of the features of the object-oriented programming. What is the feature object-oriented programming has comparing with the procedural language? OOPs go with the bottom-up approach, whereas the POP goes with the top-down approach. So the OOP says what? Irfan, you create all the classes, methods, functions, and everything and kept it in a program, right? And I am going to call that program from the bottom. That means what? You write whatever the classes, you create whatever the classes on the top. I'm going to simply call that class, instantiate that class in a form of an object and make use of it further. For example, these are all the program written in the top-down fashion. This program is written somewhere else in the top. I'm going to access this program in a bottom-up fashion. So which line will be executed out of this to execute this program? 158, it will execute first, or 166, it will go and trigger this 158 in the memory. First 166 will run to say, hey, line number 158 to line number 163, you get loaded in the memory. Like this, who will say? 166 will say. The bottom-up approach I can follow. Object-oriented will provide us a follow bottom-up approach. We don't have to maybe like load all these programs in the memory and we don't use some of them. Rather, we use only whatever we wanted, we load that into the memory. That is the bottom-up approach represents. Object-oriented programming supports inheritance. Already somebody have returned this class and kept it ready. Why I had to write this class once again? I can inherit this class in the child class. One more class I'm going to create. I wanted this function has to be, the same kind of function has to be used in the other class also. What I do? Rather than writing this function once again in the other class, I'll go and say, yeah, I want to inherit the parent class called telephone class to get this functionality freely applied, freely achieved. Rather than writing these lines of code, I want to freely get this function. From whom? From my parent class. That is the way you can use this object-oriented programming to achieve the inheritance property. I'm going to inherit rather than I'm going to earn again. But whereas POP programming says, no, you have to earn. The property what has been earned by your father will be only retained by him. He don't give you that property. Whereas the object-oriented says, no, you can incur that property. You can inherit that property. Object-oriented programming has more security with the concept of encapsulation. We can encapsulate the program or the functionalities or the values inside the program rather than exposing it to the outside world directly. Like you have a house where you have lobby, where you have road, where you have lobby or reception, or you have an office, you have a reception, or go to a bank, you have the road or the maybe like a compound area, the lobby area, and you have the office area, and you have the lockers. You have the reception in a bank or a lobby area in the bank, or you have office area in the bank. Office rooms will be there, or accountants or cashiers, whoever will be there. And you have lockers in the backside of the bank, right? All has their own access controls. I can go up to the reception, or I can go even and meet the banker manager in his room also. I can go inside the office of the bank, but I can't go inside the locker until and otherwise I have an access. Right? So that kind of access controls, the security can be defined in the object-oriented programming, which is not possible in the function-based programming, in the procedural languages. Right? This is an example for that. The controls are the access controls at the level of public, which is at the reception, protected, which is in the office room level, or private, which is in the locker level of the bank. Anything you can consider. Right? That we are going to discuss. In object-oriented programming, the program is divided into objects. In the procedural language programming, it is divided into functions. So inside the object, I have functions. Whereas here, directly I have the functions. Inside the class, I have functions which can be instantiated in the form of an object to access the function. Here, I directly access the functions. In the POP programming. What is the benefit of object-oriented programming? I'm speaking here, comparing with POP programming. Or in general, you take the object-oriented programming features without comparing even the POP programming. Security is high, reusability is there, right? Or maybe like it uses a bottom-up approach, right? And the programs can be instantiated once and accessed multiple times in the form of an object. Rather than again and again accessing and compiling the code, we can get the code compiled and stored into the memory, get accessed any number of times by using the object-oriented programming, all the features what we have in the object-oriented programming. Okay, let me go forward, guys. What is inheritance? Let's go back. Okay, so you can refer this PDF either or this PPT also. So this PPT I'll use for doing some scribbling. I may use this PPT for doing some scribbling, and I'll share you this PPT as well. So in this PPT, let's go and see what is inheritance. Right? So you have different types of inheritance used. Single inheritance. What is single inheritance? Let's try to understand. If I want to use some of the functionality or some members of the parent class, right? I can derive it in a child class. The parent class properties can be derived by the child. We call it a single inheritance. The arrow may mislead you because other batch people we used to ask, they say, Irfan, what is this B to A? Is that referring like that, or what it is referring? The B is accessing the property of A. That is how it refers. From B, I am going to A is not the concept. You are able to understand what I'm speaking? So for that, I shown them a different aspect, like you should not understand in that way. So for example, if I say, I have a table A, I have a table B. Okay, let's assume in that way. I have a table A created here. Like this, if I put, what you'll say? the data from table A is loaded to table B. Will you say in that way? If I put like this, can you say in that way? If the data from table A is loaded to table B in Hive or wherever. In the other hand, if I say like this, if I say like this, what do you say? Irfan, the table B is joined with table A, are referencing the table A. Now the B and A is getting loaded to C. Will you say in that way? We don't say B is loaded to table A. We say it is referring. We say I'm referring, I'm joining B with A and I'm loading to table C. From top to down or left to right, we may mention this arrow to say it is loading. If I mention bottom to up, right, or right to left, like this, if I mention like this is a reference. This is a reference, not copy. I'm not copying. I'm not copying data from A and loading to B. I'm referring by B, the table A. This is a join I'm doing. A reference I'm doing. There is a difference. So here what it says, the class A contains function F1. Class B contains function F2. Now class B contains how many functions if it refers class A? F1 and F2. You agree? Very direct. F1 and F2. That is inheritance. The class A is otherwise called as a parent class. The class C is otherwise called as a child class. The class A is otherwise called as a base class. The class B is otherwise called as a derived class. In any terminology you can call it as parent class, child class, base class, derived class. Anything you can call it as in the terminology wise. Now the parent, let's take an example of the father. I'm taking that as an example with you guys also to discuss it easily rather than complicating this concept. Let's try to understand the concept first. Father has earned an amount of 10 lakhs rupees. Son have earned an amount of 5 lakhs rupees. Right? If son needs 15 lakhs rupees to do some business, what he can do? Tell me guys. Son, the father have earned 10 lakhs rupees, son have earned 5 lakhs rupees so far. He wants to do a business. So he needs 15 lakhs of amount in his hand to start that business. What he can do? The son can go and inherit 10 lakhs from the father to get 15 lakhs acquired to start a business. Or what he can do? The son can be standalone and say, I don't inherit. I can earn the 10 lakhs amount for another few years and then I can go and start the business. He can tell him that way either, or he can go and incur the money from his father and he can start the business. Anything can be done, right? But which one is a more better way to achieve by the son? Which is a more maybe like a better way to achieve this? Hey, let me get it from my father. He already has inheritance. So we use the concept of inheritance here. That will be provided by the object-oriented programming. That is what we are going to see in implementing it. Okay, let's try to understand that. First of all, a simple inheritance or a single inheritance we used to call it as. Okay, let's try to understand that, guys. Inheritance, there are different types. Single inheritance. I'm having a class created. The name of the class is father. Father has maybe like acquired. Let me use the same example I used earlier also. Father have created a land. Okay, very directly I'm going to create a class attribute here just to show you the concept. Father have created a land or purchased a land for 2,400 square feet, 1 ground of land he purchased. And the son wanted to construct a house, right, for around 1,500 square feet. Out of the 2,400 square feet, he wanted to construct a house of 1,500 square feet. Now, if I'm going to create an object for the sun, right? obj1 underscore sun is equal to our sun 1 or sun obj1, anything you can name. Sun obj1 I'm creating to instantiate this sun class, right? So the sun class is getting instantiated in the memory. I can go and say, hey, sun can construct a house of how much square feet? House square feet, 1,500 square feet. Let me put all this concept in a separate notepad and separate program, and we'll get it merged in this program. Okay, I'll keep this in a Scratch program. Basically, these classes and the classes will be created in a separate program. I go and refer the class. I don't go and directly instantiate the class by keeping it over here. Do you agree? I'm keeping everything inline just to learn it easily, right? So I'm using the term called obj1 dot this house to access the house. So this obj1 is showing only what here? When I type dot, it shows only the house member. Only the sun can construct the house on top of what? On a land of question mark. I don't have a land to construct. The sun have only earned the money for constructing the house of 1,500 square feet. He don't have a money to buy a land, or he don't have a land at all. Can he construct this house? He can't, right, guys? So what he is supposed to do, either he have to learn or earn a land. He have to buy a land. He have to buy a land. So what he can do, he can say, hey, I can construct the house on top of the land that I purchased. Doesn't matter. He got that fulfilled. He can get the house constructed on a 2,400 square feet land, what he is owning directly. But is it mandatory? Is it really needed? No, not needed. Why? Because already the land is purchased by the father. Let him use that. Father, what is supposed to do? He had to inherit the father's property. So, son can inherit from the father by using what type of inheritance? Directly, when a son inherits from a father, the son is nothing but a what class? Child class, or maybe like a derived class. We call it in any name. If we are going to consider this as a parent class or base class, I'm going to call this not as a single normal class. I'm going to call it as a base class. If the son is going to accept, okay, father, I'm going to accept you as my father, or I'm going to accept you as my parent class or a base class. You are the base for me. If I'm going to accept from you, I'm deriving something. Like this, if I'm going to accept, then you have to not pass the father as a parameter. You are going to consider this father as a inherited property or as an inheritance class. So you are going to consider this father class as a base class or a parent class by inheriting. This is not, you are passing an argument. A class is an argument to another class. This is considered as a inheritance. We call it in a different terminology. Not as what? Not as maybe like passing an argument. Don't call it as a passing of argument. You see here, automatically it is telling something here. Hey, it's the subclass by son. Right? It's subclassed by son. The son called this parent. Automatically is putting some reference here. If I don't put like this, it becomes standalone. You got it, guys? Now what to do? This will still work. If I don't do this, it won't work. It will throw error. What is this land? I don't know. Unresolved attribute. It is throwing error when I run this. Sun object has no attribute land. Sun does not have a land. But whereas if I go and accept, okay, let me inherit from my father. Now the sun has a land also. This land is not coming from the sun. Actually, it is coming from his father. But still, sun has full rights on accessing that land where he can construct the house on top of it. Clear about what is inheritance, guys, fundamentally. So already I have written lines of code in a form of functions or in a form of def. I have a function. Maybe father have earned a money of some amount, right? $10 lakhs he earned as an amount. Now the son wanted to access that amount. Right? What he can do? He can go and say land of so and so with the amount of so and so. Sorry. So he have to say, I can get the money from my father also. So why I'm showing this, right? I can just get a money which can be returned. So now what he can say, what I'm just trying to convey here, the function also can be accessed, not only an attribute. If you think like only an attribute can be accessed from the father, not really. We can access the functions also. So the attributes and the functions can be accessed from the father class. So he don't have to have a function created here. He can directly access the function created by the father. So with an amount of so and so. Amount function has been created by the father. Okay. Whatever the amount that the father have deposited in the bank, I can able to get that. This is single inheritance case because the child class or the derived class is deriving from one parent. We call it as a single inheritance. What is the benefit we are getting here? The benefit of single inheritance or inheritance is reusability. Benefits are reusability, reduced lines of code, right? And then maybe like improved performance. We don't have to write the huge lines of code and instantiate all the codes. Modularity. And maybe like having a better access control or better uniformity. All these features with the help of inheritance I can achieve. So for example, if the son is not going to inherit the parent property, but the functionality what is applied here, the amount plus what are the interest he earned in the bank. The interest is 1 lakh rupees what he earned or 10,000 what he earned from the bank. The same kind of functionality I have to apply in the function that I create inside the sun also. If I'm not going to use one common function. So I get a better modularity and better uniformity as well. Uniformity means uniformly I'll maintain the function in one class. I can use the function in other classes whenever it is needed. Rather than recreating this function, I can reuse. So reusability is the primary feature of the inheritance. And there are different types of inheritance. Single inheritance means what you understood here. Everybody, let me go forward if that is the case. Okay, let's go with multiple inheritance. Now you guys can tell me what is multiple inheritance. How can I create? I don't want you to write a program, but just tell me what additionally I can do to get multiple inheritance achieved. What is multiple inheritance? You see the image and tell me, right? What is multiple inheritance? See this, you can understand. If we have more than one base class or more than one parent class for a child class, we call it as what? Multiple inheritance. I'm going to inherit the property from multiple people, from my father and from my mother, right? That is multiple inheritance. The child class is going to acquire the properties from his father and the mother. Inherit from more than one parent class, not only two parent class, more than one parent class. Maybe the child is inheriting from his father, his mother, and his siblings also. His elder brother also is going to give some money to the younger brother, younger daughter, younger sister, whatever. That may happen, right? Right? So you don't define as two parents, more than one parent. Not only two parents. You can incur from any number of classes, doesn't matter. Right, Visagan? Now I have a father who is going to give the land to me. I have a mother class who is going to give what to me? Maybe the money to me. Father is giving the land, mother is giving the money. Let's separate this. See, earlier father itself had both land and the money. In this case, I don't have everything in the one class itself. Every functions or every attributes are not created in one class itself. It is spread across two different classes. Now, the land I can incur from the father, but where is the money I can get from? Unresolved attribute, I'm getting an error here. Now what I'm supposed to do? Multiple inheritance. What is single inheritance did I mention? Single inheritance is if a child class inherits from one parent class. Direct inheritance or single inheritance we used to call it as. Or a simple inheritance also people used to call it as. If a child class is going to inherit from multiple parent class. More than one parent class, then we call it as multiple inheritance. So now, in order to fulfill this, what I'm supposed to do? In order to avoid this error, I'm getting an error in the second iteration. First iteration is completed, single inheritance is completed. But multiple inheritance is failing. If the child class inherits from more than one parent class, I'm getting an error of saying what? Hey, where is money? You are using some money from your father class. You inherit only the father class. Where is the money? Money is not with the father. It is with the mother. I have to do what now? I have to add mother also over here in my inheritance. Very direct. Now I'm inheriting from the father and the mother. Done. Now you can go and lavishly construct the house. This is multiple inheritance. Following me, guys? I'm creating an object only for the son. But the son is inheriting from the father and the mother. I'm not creating the object of father and the mother. When I inherit the son, when I say a son can inherit the property from the father and the mother, he'll go and automatically incur these values from the father and the mother. Automatically. Okay, done. This is multiple inheritance. What is multi-level inheritance? Or we'll see about what is hierarchical inheritance. These two are the balanced types of inheritance we have. What is the, maybe let's go with multi-level inheritance. What is the multi-level inheritance says? If one class inherits from other class, I can inherit from that class which inherited some other class. That means what? The child class can inherit from a parent class, which could be the child of other parent class. So you can put a relation like this. Grandfather inherited a property. Father is inheriting from the grandfather, and father is having some more property added. I'm inheriting from both of my father and the grandfather. Father also used some property from the grandfather. I am using the property from my father and the grandfather. You're able to understand, guys, why people are relating inheritance with the ancestral property. When I was asking, guys, inheritance, you are immediately telling ancestral property, inherited property. We always say this term in our real life, right? The same thing can be applicable in this learning also. Take it in that way and learn. Now, when you open this program, you can get a better clarity. Any program you open, right? You can see here, what is this? What I mean, very simply say, this line, what you can call it as now? It is doing what now you can call it as? Single inheritance. We'll call it as like that by saying, oh, okay, this class, this is a class, it seems to be. This class is getting a parameter passed like this, you are feeling, but it's not a parameters passed, it is an inheritance. Oh, this class is inheriting some of the properties or maybe all the properties from other class. Maybe this class may be kept in some other programs. We don't know where this program is kept. We might have imported that from somewhere else. So from PySpark.sql.pandas.conversion library, this Spark conversion mixin class is present. Maybe we can go there. sql.pandas.conversion.py file. There is a program called Spark conversion mixin program is created by somebody. Now this program is taking another program as an object or another program as an input. Something called as an object as an input. Something called an object as an input. This guy have taken. We can call it as what type of inheritance now? When we were seeing there, we were calling it as a single inheritance. Now we can call it as what type of inheritance? Multi-level inheritance. That guy is telling, my Spark session is telling my parent is this guy. I'm inheriting from my father. This guy is telling my father is an object which was created by somebody. Maybe it could be an object also or a class also, doesn't matter. So this guy is telling what? My father is object. And the other guy is telling my father is, the Spark session is telling my father is Spark conversion mixin. Now very simply say, the Spark session can now use some of the functions which was not created over there, which was created here. Create data frame is a function the Spark session can use. It is allowing me to use this function. I did not type everything. I just typed create DA tab. It is automatically expanding. That shows what? Did I have this Spark session? I loaded only Spark session here. If you see, what program is loaded in the memory in the object format? Spark session class is loaded in the memory. But do we have this program called create data frame in Spark session? Do we have this program called data frame in Spark session? Oh, okay. It seems they have. Then this shows what feature? This create data frame is present in the Spark session also. But we are inheriting from a parent, and there also we have a Spark create data frame. What that represents is overriding concept. Let's not get confused. Okay, let's take some other program. This shows me, hey, they are doing a overriding. That means what? Hey, father, you might have earned a property that we are going to discuss next. Okay, father, you might have earned a land of 2,400 square feet. I don't want to use 2,400 square feet. I want to use 4,000 square feet. So I am going to even acquire a land. I'm going to even buy a land. Despite you have some functionality applied, I'm going to override your feature. Like this, I'm going to say here. So now what will come into picture here? Here you automatically see something called overrides attributes in father. Overrides means you have a land, I'm okay. Let me use some other property from you, not the land. Land I'm going to earn off my own, because the 2,400 square feet what you have purchased is not enough for me to construct a house. That is what have happened here. I mean, like by looking into this, I'm connecting the dots. I did not see this program and gone through and remembered or maybe like memorized and all. I'm just opening on the fly with you guys. I'm finding, oh, okay. This session.py is incurring a program called spark conversion mixin or whatever as an argument or as a inherited class. Where this program is present, it is present in this library. So I'm opening that program, the conversion.py module I'm opening. In the conversion.py module, I'm finding this program is inheriting one more program. So I'm calling it as what? Multi-level inheritance. Now, why this guy have inherited the session.py? Why he have inherited a parent program? Because the parent program has some more additional functionality. What are the functionality he has? There are two classes created in this program, it seems. One is Spark Mixin and another one is a Pandas or whatever the program. So here they have some program called create data frame, or they have other functions like convert from Pandas, or they have some other functions like len function or get numpy record types or something like this. They have a lot of functions they have, it seems. This guy have a lot of functions, it seems, especially these functions. Now, the create from Pandas with arrow. This is a function what those guys have created. Who? This mixin program I've created. Now the Spark session might not have the same program available in his environment. You see here, it is not available. But I may have that program incurred here. It is automatically expanding with the arrow. Did I do anything? So what it proves is Spark session. You have some functions already available, right? And some more functions you are getting it from where? From the mixin program, from some other program which was created under a different library platform. You able to understand, guys, what I'm speaking? But some program what was created by them, you are not using that directly. Some program you are using from him, maybe from the father you are using some maybe like wood, what he have earned. He got some wood of maybe like timber wood what he have of maybe teak type wood what he have earned, father have earned. I'm going to use that timber teak for constructing my house, but not the land. Land is being owned by the father. I'm not going to use that. I'm going to override that. But I mean like timber created by the father, I'm going to use that. The same thing is applicable here also. One function which was created called data frame, create data frame, I'm overriding that from my parent. Despite I incurred my parent, I'm not going to use that function of what is created called data frame by my parent class. I'm overriding the data frame. But the function is not available with me called create whatever that function that we have seen. The pandas with the arrow conversion. This one is not available in the Spark session, but it is present in my parent class. So I'm going to use this function separately from my parent class, and I'm going to override an existing function. Create data frame function, I'm going to override. And I'm not going to use that function provided by my parent. I'm going to use my own function. This is also possible. We call this concept as an overriding concept, which we are going to learn next in a different topic. So by looking into this program, right? Needless to look into this program. Needless to go and open this program. But what we are trying to understand here, the framework developers applied all these concepts in the background. Our work is not applying the same concepts in the background. Our work is simply doing what? Creating a Spark session object and leveraging the functions, not all the functions. The create data frame is an important function. And the function what I have shown, we never used. Finding the difference? It varies. Maybe internally this create data frame may use that other functions also. We don't know. Right? Very clear, guys, what I'm speaking. So by opening this program, we are able to understand, means that is because of we learned about what is OOPS. We did not learn it fully, but just I'm giving you an idea. I went to do something, it was showing some other things more internal. But what we understood here is the framework developers have applied this concept of multiple or single or maybe like hybrid or whatever the hierarchical or multi-level, all the inheritance internally. We found they implemented what inheritance? Now what type of inheritance and all they implemented, you see here and tell me. We have seen two types of inheritance they used in their program. Single and multi-level inheritance, right? We were able to realize that by looking into it. But we don't have to worry about thinking about all this inheritance and all. Once for all, let's try to know. But you get a better clarity now, guys. So now I'm using what type of inheritance? Let me not go with overriding and all for now. Let it be. They used overriding concept also internally. Let's forget about it. So multiple inheritance means what? One child class is going to derive from multiple parent class. This is multiple inheritance. You are all clear in the multiple inheritance case. Now let's go and expand this with what type of inheritance? Maybe like hierarchical inheritance. If a child class inherits from one parent class, and or I could say in another way, if a class inherits from another class that got or that was inherited by some other class, we call it as a hierarchical inheritance. Or a class can inherit or can be inherited. We can take it in that way, very simply. A class can inherit or can be inherited. We call it as hierarchical inheritance. Able to understand? Now, I'm having a grandfather class. I'm having a father class. I'm having a son class who is going to inherit from his father. Son is inheriting from the father. Father is inheriting from the grandfather. Child class number 1. Child class number 2. Now, the grandfather have earned the land. Father have earned the money. Son is going to construct the house. Okay. People used to get confusion here. Whether, okay, yes, I mean, even I'm getting this right. So it is a multi-level inheritance. Like hierarchical and multi-level will be used in a mixed way. That is not correct actually. Yes, multi-level inheritance. It is a multi-level inheritance. I wrongly mentioned. Multi-level inheritance. I'm going with multiple levels of inheritance. One level I'm inheriting. Second level I'm inheriting. We can go with more levels also. Any number of levels we can go as well. So now this shows what the grandfather earns the land. Father earns the money by using some functionality, not direct value. I always don't think we can only use direct value here. We can use functions here. Doesn't matter. This class can be separately used for a different purpose. This class can be used along with this class for a purpose. Or this class can be used with this class and this class can be used with this class. So the son is incurring all the classes. So all the classes can be used separately also. Okay, so don't think they are all has to be used together. But if the son uses the father can be directly provided or can be inherited and provided, doesn't matter. Like what we have seen in that example. The Spark session program is inheriting the Spark mixin program. That mixin program is inheriting an object. So that was a multi-level inheritance example. So now the same thing can be achieved with the help of the multi-level inheritance. The class inherits and it can be inherited by some other class. We call it as multi-level inheritance. With me, guys? With me? Let me comment here for a reason. So here, what is the difference you are finding? Answer, we are getting the same for all of them. We are getting the same thing printed for all the types of inheritance. Right? Then why we need this many types of inheritance? Why not we can achieve the same answer by having one type of inheritance, even a single inheritance made? If we have a single inheritance made, all this land and money has to be owned by this members has to be owned by one class itself. But that is not happened. One class has one functionality, another class has another functionality. Then I'll go with multiple inheritance. If one class, if I need some functionality which is already taken care by one parent class itself, I'll go with single. If the functionality whatever I require, such as land and the money, which is being maintained by two different parent class, then I'll go with multiple. If the property what I wanted is managed by not one class, by multiple classes, and that too, I don't want to inherit directly from both the classes, because already one class I've inherited. My father already have inherited from my grandfather. Then why again I have to inherit directly from my grandfather and from my father? I can get from my father, which in turn inherits from the grandfather. So why I have to go with multiple inheritance here? I can go with the direct inheritance of my father itself, but that leads to a multi-level inheritance. I feel like I'm just inheriting from my father. Since my father is also inheriting from some other class, this will become multi-level. So on the need basis, we are using the different types of inheritance. Right? So automatically, if I inherit from my father, I'm inheriting from my grandfather also, which goes multi-level. Right? The fourth type of inheritance. What is that, guys? Hierarchical inheritance. I'm going with a hierarchy. Like you can say a manager, two developers. Like this, you can go with a hierarchy. Hierarchical inheritance represents what? The reverse of multiple inheritance. If a child class inherits from more than one parent class, you can take it reversely. If the child classes, if more than one child class inherits from a parent class, we call it as hierarchical inheritance. Okay. I have two childs here. I have son and a daughter. Son and a daughter I have. So from the father, I'm going to inherit from son, and by the son and the daughter, it is going to be inherited. Okay. Daughter inherits from the son, from the father. This is hierarchical inheritance, right? So the son and daughter has the same hierarchy. They have the same rights to inherit from the father. right? So whatever they wanted, so daughter wanted to construct a house of 2,000 square feet. Son wanted to construct a house of 1,500 square feet. Let them construct. What is the problem? That's it. This is hierarchical inheritance. Got it? No problem. So if so apologies, okay. I have this question. Father inherits from grandfather, but still son is inheriting from both the classes. Will it behave like multiple or multi-level? Okay, that is what I'm telling, right, Vishagan? You are inheriting from, so you're talking about this multi-level inheritance, right? Son inherits from the father, father inherits from the grandfather. You think in the term of not from the son. You think in the term from the father, from the grandfather. Somebody wanted to only access this attribute from this class. They can instantiate only this class. Somebody wanted to access only the land and the money. They'll inherit from this class. They'll instantiate this class. Somebody else wanted to access the house also. In that case, only they'll go and say, hey, son, you inherit from your father. Already the father have inherited something from his parent class. So why you are going to inherit from both grandfather and the father? By that way, we are going with multi-level inheritance. So your question is, here you are finding he's inheriting from the father and the grandfather. So that represents, you can call it as a multi-level inheritance or a multiple inheritance also. Because he's inheriting from two classes, but not directly referring the two classes. You got the point? So think from the other perspective. If you see from the son's perspective, you may feel like, hey, Irfan, even I'm asking you this question, right? Why not we can achieve using single inheritance? Why we think about even multiple, multi-level, hierarchical and all? The same answer I'm getting for single inheritance also, right? Why you are not thinking in that way? Think from not from the son's perspective alone, think from the father perspective also. Right? The father can be directly accessed. Our son can access the father also to get some features achieved. So these two programs can be instantiated separately also. In that case, you think, right? The father has some property, mother has some property. They can be used separately. If they are combinedly used, then it is a multiple inheritance or whatever, right? Very clear, guys? Conceptually, you can say, hey, looks both are similar, or even single looks similar, multiple looks similar, multi-level looks similar, everything looks similar in terms of achieving some functionality. But think from not from the son's perspective. I had to create objects for others also to make that understand. If I create for mother, somebody can access the amount from the mother. If I create for father, somebody can access separately the land from the father. But I want to acquire from both of them. Here, I don't have an option other than using multiple inheritance. If the son wanted, this is how the classes are created by somebody. Now I am going to create a class where I need the attributes of father and the attributes of the mother. Then what type of inheritance I use here? I can't go with single. I can't go with multi-level. I can't go with hierarchical. I have to go with only by multiple. Very clear? I don't have an option here. If I'm telling guys, we have these two classes available in front of us. I wanted you to access the attribute one of the class called land and the attribute one of the class called money. From the father I wanted, or I want land and the money. Like this, if I say, what you'll do? You don't have an option. You have to go and ask your father and the mother to get this two acquired. We don't have an option to escape from the multiple inheritance here. But if I say, no need of getting the money and all, bring only the land. Like this, if I say, then you can go with what type of inheritance here in the given point of time? Just a single inheritance will do. But this is how the things are organized. Already somebody have created a grandfather class. I can't avoid that. My grandfather have purchased the land 80, 70 years ago. I can't avoid that. I can't stop him purchasing a land at that point of time. This is already created. And my father earned some money 20 years ago. I can't stop that. I wanted either the property from my father, it is inheriting from the grandfather. I can't stop that because for his purpose he inherited the land from his father. I wanted either the land money alone, or I wanted even a land also I can inherit, because already this is how it has been inherited. I want only the land. What I'll do, I'll go and inherit directly from the grandfather. It will become single. Since I want money, I'm inheriting from my father. But along with money, since the father inherits from the grandfather, I can inherit the land also if needed. Not mandatory. Not all the functions you are supposed to use. Rather, you can just use only whatever is needed. That option as well we have. Hope you are with me in this case. Give me a second, guys. Fine, guys. Let's go forward. So you understood about all type of inheritance. Good with that. Shall we move forward to the next item? Right? You can go with any types of inheritance. Okay, doesn't matter. Let me go to the next item. That is what? What is the next item, guys? Inheritance is the first priority item. Second priority item is polymorphism. Polymorphism, which consists of two concepts: overloading and overriding. Okay, two concepts it has. So what is the topic number we have here? 10th one is the OOPS fundamental, right? So 10.1 I'll put here. 10.1 is inheritance. 10.2 is polymorphism. By putting this number and all, you should not miss any of the topics whichever you want to refer. Okay. What is polymorphism means? Tell me, guys. Poly means what? Multiple? Poly means multiple. Morphism, right? Or many. Okay, I can put many. Forms, excellent. Many faces. Or many shapes. Anything you can mention, doesn't matter. Morphism. I'm morphing, I'm changing. Right? So to see it more better, let me go and show you the PDF. Yeah, I mean, I take an example of student, right? The student can show his different faces, depends upon the different input that you are going to pass to him. Or a person can take different, maybe like shapes or forms, or he may be showing his different face, depends upon the different input that you give to him. Depends upon the condition, yes, the situation, right? The activity or the maybe like the feature of me will be changing. Take it as an example over here. Polymorphism represents what? Take the term called polymorphism alone. Different faces of a person is being shown in different places. Depends upon the input that I pass, the output will be varying. So a person can behave like a student in the school, or like a passenger in a bus, or like a customer in a shop, or like a son in my home. Right? That is polymorphism in general. How can we achieve polymorphism? What is the polymorphism represents in terms of the theory? How can we achieve using polymorphism? Polymorphism is a different story. Indicates The function can come in many forms, right? It can be used for different features. The function that can say very directly say, if a program accepts different types and number of arguments and returns different results accordingly, we call it as a polymorphic functions, or we call it as polymorphism. Depends upon the input, the type or number of input that you are passing, number of input, the result varies. Maybe you can call it accordingly. The result varies. We call it as a polymorphism in general. If a program or a person who accepts different type, different input, different type of input, different number of inputs, I show the result differently. That is called polymorphism. I show my different face in different places, depends upon the different circumstances, different inputs, different numbers or different types. Right? I feel more cold when I sit in the AC. I feel more hot when I go and stand in the sun. Right? I may get sweat if I stand in the sun. I may feel cold if I stand in the AC. That is polymorphism. Okay, fine. So literally says what Vishagan is mentioning is correct for overloading. So polymorphism can be achieved by using, or there are two concepts comes under polymorphism: overloading and overriding. Overloading is nothing but function with same name, but different in number of arguments, in type and number of arguments, if we pass, behaves differently or returns results differently. We call it as a overloading concept of polymorphism. Polymorphism is a common concept. A program accepts different number types of arguments and results differently. That is polymorphism in general. A program or a person who accepts different input and results differently or behaves differently or behaves accordingly, we can call it as polymorphism in general. The polymorphism can be achieved by using overloading and the overriding concepts. What is overloading? First see, then we'll go with overriding. Okay. What is overloading? First we see. The function that takes different forms in general, or the function that takes different input type or different number of input and results differently, returns the respective result accordingly. We call it as a overloading concept. Okay. What is a literal example for overloading? If you take in general with whatever the learning that we made, I told like we learn about it formally, then you can understand this, then you see this len function differently. I'm having a variable of str1. I'm having a variable of lst, right? Both has the same content, inceptez. But when I pass this two different type of value to a same function, the function with same name, but different in type of argument, do you agree? I'm passing a different type of argument. One is a string argument I'm passing. It is returning differently. Number as 8, it is returning. The same value that I have, when I pass it as list, it is returning differently. We call this len as what type of function? So polymorphic function uses the concept of what? Uses the concept of overloading. uses the concept of overloading. Okay, now leave this len function. You understood about len uses overloading, guys? Do you agree? We can call len as a overloaded function. Take very simply this len function. Example is len function. I'm having a list created. I'm having a string created with the same content. But when I pass that to the len function, it returns the result differently. Results differently. We call it as overloading concept. The different in type of argument. Different input types with different results. I'm passing a different type, getting a different result. I'm passing different number of arguments. Let me take an example of some function like sc dot parallelize of range of 1, 10, 2. I'm passing as an argument and I'm going to collect the result. I'm getting a result of 10 values converted into an RDD and collected as a result. I'm creating an RDD with an RDD1 with, just as an example I'm speaking, with a function called parallelize. The parallelize function will do what? If I'm going to pass some range of values with a second argument, one argument is a range of value, the second argument with the number of partitions. If I create an RDD like this, and if I put get num partitions, it shows 2. But whereas if I go and call the same parallelize function without passing the second argument, it returns the result of how much? 4. What does it mean? This function parallelize is what type of function then? It is a polymorphic function that takes different in number of arguments and results differently. What is this function we are doing here is, we are creating an RDD, resilient distributed data set. We are going to learn from the second half onwards, this part only. Resilient distributed data set I'm creating by using a function called parallelize function, where I'm going to use the Spark context as an object. The Spark program, the Spark core program is loaded in an object called SC. Spark context is a class which is loaded in this object called SC object. The SC object that parallelize function I'm calling. This parallelize is created as an overloaded function. This is an overloaded function. It has a polymorphic feature implemented. This function says what? Hey, Irfan, you can pass different number of arguments. How many arguments I'm passing here? How many arguments I'm passing to this function parallelize? 2 arguments. One argument is a range of values. Another argument is number 2. Some number I'm passing. 2 arguments I'm passing. Argument number 1, argument number 2. The function that takes different number of input parameters or input arguments and getting the result, saying what? Hey, Irfan, if you call a parallelize function kept inside the Spark context class, which is instantiated in the name called SC object, you loaded the Spark context program in the name called SC, an object you created. The class called Spark context is loaded in an object called SC. If you use SC dot Spark context dot parallelize function, if you call from the Spark platform, you can pass 2 arguments to that. One is the range of values, which has to be parallelized, which has to be converted to RDD. And the number of partitions you want to divide this RDD into 2 portion or 3 portion or 4 portions. If you pass the second argument with some value, it will consider this value and it will convert the RDD to that many number of partitions. Here the same function is called with how many number of arguments? Only how many arguments I'm passing? Only 1 argument. Still it is accepting. It is creating, it is converting this data into RDD of how many partitions? It is dividing this data into how many pieces? 4 pieces, not into 2 pieces. It is dividing it into 4 partitions, 4 pieces. So this function is a polymorphic function using the second concept of overloading. It's an overloaded function. It uses the second concept of overloading. The different number of input arguments changes the results. Agree? The second part, what we are discussing here. So I'm creating an RDD. I'm going to get the number of partitions. It shows how much. Maybe try it in the command line interface. Later we'll take it into our VM. I mean our Python environment and all, the PyCharm environment and all. So this shows an example of function with different number of argument returns different result, but the same function with different number of arguments. So different number of arguments with different results. You are finding the different result. This here were 2 arguments we are passing. Here we are passing only 1 argument to this function. So parallelize is a overloaded function, polymorphic function. So the function with same name but different in type of argument that you pass or number of argument that you pass will provide you the results accordingly. Maybe with respective results I can mention. Not different results, respective results. Depends upon the input that you give to the person, he will respond to you. It depends upon the circumstances. He behaves like a student or whatever. You understood what is overloading concept in polymorphic feature. And in overloading, we can pass different number of arguments or different types of arguments to the same function, which returns differently. Understood? Can we achieve overloading? Overloading is a feature of object-oriented programming. Can we achieve a question? Overloading in Python. For example, let me show you guys how do we achieve overloading in Scala, taking a minute of time. You guys tell me in the same way can we achieve in Python. Class, ABCD class I'm creating, where I'm going to define 2 functions. Def function 1. Function with same name, right? With different in number of arguments. Okay, let me just create this function. Okay, so I'm going to return square root of maybe like a function. If I call f1 by passing 1 argument, it will return square root of the value what I pass. If I call the same function f1 by passing 2 arguments, this is in Scala. Forget about Scala. I'm not teaching you Scala. I'm showing the feature of the overloading concept here. Okay, guys. We created a class with 2 functions with the same name, but can accept different number of arguments. You are with me? What I'm speaking? We call this function as what type of function? Polymorphic function or overloaded function. In the polymorphic feature of object-oriented programming, overloaded function. We can call it as a overloading function or overloaded function, or call it as a overloading concept. Anything overloading and altogether we have to know. Now I'm creating an object for this class equal to new ABCD. In Scala we can't use the open and close bracket. Rather than open and close bracket, we use a term called a new. New means what? Hey, construct a new memory area to load this class called ABCD in memory and refer that memory by using this object. Like this I'm telling in Scala. So now what happened? The ABCD class is loaded in a form of an object in the memory like this. It is telling, hey, in this memory address, I loaded this ABCD program, ABCD class, like this is telling, like how Python told. The same thing is Scala is also telling me. Maybe in Python, if you have to create the same class, what you do? Class ABCD colon, you put def function 1, function 2, all this you mention. The same way in Python also we can do. I'm doing it in Scala to show you guys the concept. Wait for a while, I'll show you. So in Scala, I'm having two functions created with the same name, but different in number of arguments. We call this function F1 as what type of function? Overloaded function. What is the benefit I'm going to get? obj1 dot F1 if I call with 10, it is going to return me how much? The result? It is going to call which function out of these two? The first function it is going to call. Depends upon the input, the respective result I'll get. A into A, 100 I'll get, the square root of 10 I'll get. If I go and call the same program with 10, 10, what it will return? It will return 20 because it will call this function. Depends upon the number of arguments, the respective functionality will be called. Depends upon the environment, right? I call my respective functionality. When I go to shop, I'll call the shopping functionality inside me, inside my brain. When I go to school, I call the learning functionality. But the function names remain same. Depends upon the input that you pass, the result varies. This is called overloading concept in object-oriented programming language. The same concept can you try to apply in Python, guys? Let me try to apply the same concept in Python. I'm going to copy this code and modify according to the Python programming language. Okay, let me put the same code in of the Scala program over here for your reference. This can be achieved by arbitrary argument function. Excellent, Rajkumar. Yes, true. My question is whether we can achieve in the same way like how we achieved in Scala. That is my question. In Scala, we achieved like this very easily. Do you agree? Did we achieve this easily? Let me try to achieve the same program or the same concept by using Python. That is my question. Class ABCD. I'm creating function 1 like this, where I had to create the function 1 as F1. The syntax varies a bit, right? Syntax varies a bit. Again, I'm going to create one more function, which is going to take two different arguments, A and B. Maybe I'll use self keyword because in Scala, you don't have to use the self keyword and all. Directly, we can define a function. It will automatically refer this class dot this function name like that and all without using even the self. But whereas in Python, we are being tricked with self keyword used. We have to use the self keyword obviously in the Python programming language, not in Scala. You see in Scala, it is pretty direct. We did not use the self, all this and all. Directly, we created a class, we created functions and called the functions. But whereas Python, it uses a self keyword. We have to obviously use. And what I'm trying to achieve here is A and B I'm passing as an argument, and I'm going to do A plus B. Fine. Now what it is throwing as an error here? Irfan, redefine the function F1 above without the usage. What it is telling, you redefine the function. So create an object, obj1 equal to ABCD of the equivalent of this program in Python. In Scala. Scala we did like this. In Python we did like this. Scala we have to define this object one is a value or a variable type. Here we don't have to mention anything. Everything is variable in Python. In Scala we have an option to say whether it is a value. Value means what? Static value. Or it is a mutable or immutable we can define here. But whereas here we don't have to mention. It is a variable. We can change the type or we can change that values. Whereas here we can't change the value, we can't change the type. so easily in Scala. That is a different story of Scala. Forget about it. I'm creating an equivalent ditto program in Python to see whether it works as like Scala or not. I created an object. I'm going to call that function. I'm calling the function. What it is doing? It is accepting if I call with one argument. If I go and call with two arguments, it is not accepting. It is going to throw error. Hey, sorry, F1 is missing one positional argument B. In fact, what it is telling? I need one more argument to be passed here. Otherwise, I don't work. It is throwing an error here itself. In the line number 84, it is telling Irfan, I'm expecting one more argument to be passed. So it is calling which function here? It is calling only the function with two arguments that I passed. It is not allowing me to call the function with one argument. So what you can conclude here now? What you can conclude here? Can we overloading in Python? Let me ask you one more question directly. As like other languages. No. I'm going to use the answer of our team member, Raj Kumar. This can be achieved by using arbitrary function, arbitrary argument, or arbitrary keyword argument. Or default argument. Functions. With me now? This can't be achieved directly, but it can be achieved by using. It can be achieved by using. See, overriding means it's not overriding, Piyush. Overriding will be applied between the classes, not within the class. Okay, if I keep this function in another class, then it is overriding. Okay, overriding we have to see. Wait for a while. This is not at all possible for me. This is not possible for me. So what I'm supposed to do for this to achieve still? Not possible. Not possible as like other functions. So what I'm supposed to do for achieving this? I have to go and change this type as either arbitrary argument function or default argument function. And I have to go and say if default value is passed, both the values are passed, then you accept the as a addition or multiplication or whatever the square root, whatever you can consider. The best way to achieve is using arbitrary or an arbitrary keyword argument functionality. So I put star before this here. Then I'll say what? If the len of A is equal to 1, then you go and call what? A into A. Else you call what? A plus A. Very simply I'm achieving. But for every cases we have to apply this functionality, this check inside, which is not so direct, so easy, but still the Python does not support overloading directly. We have to achieve by using, not directly. But this can be achieved by using the concept of all these arbitrary keyword or arbitrary or default argument functions. Now what we can do, we can achieve this. Pass one argument, you will get the result of square root. Pass two arguments, you will get the result of addition of two values. How? Of 0 we have to mention, of 0 you have to mention. Because I am passing only one value in this argument, only one value. If I pass multiple values, now you can get this achieved, the same functionality, 120, what we achieved here. We achieved 120 as a result, same result, no changes, but not directly. As like Scala, we can't achieve. That's the reason I taken you to the Scala. With me or not, guys, in this? How can I achieve overloading concept in Python? Overloading means a function with same name but different in number of arguments or type of arguments, doesn't matter. Type of arguments. The type of argument I'm going to use to perform some operation. Then what you do? You go and pass some arguments here, check for a given type. The A of 1 is an instance of integer, is an instance of float, is an instance of string, is instance of, you guys were discussing in the WhatsApp and all, right? You can use some methodology to achieve that. Check for whether this input argument is an instance of so and so. If that is the case, then you go and apply some functionality. Otherwise, you apply some other functionality, type of argument that you pass. So in Python, overloading can't be achieved directly. Not so direct as well, not so simple as well. We have to handle it programmatically like this. Hope you are with me in this. Overloading means what? How can we achieve the overloading in Python? You still have to, yes, you still have to get it, Visagan, right? We'll go back to your question after we complete all this, okay? Let me go back. So overriding, what is overriding, guys? Overloading is a concept what you have seen so far. What is overriding? One of the concept of polymorphism is overloading. Another concept is overriding. Function with same name, right? Across different classes returns or has different functionalities. We call it as a overloaded functions, overridden functions. What is an example for that? Overriding. So go and see this PDF, you can understand. Overriding says what? You go to a shop and buy pizza or burger or whatever, right? You don't want it to just have that burger as is, right? You want to maybe like add some more feature to it. Or you want to have your own implementation of it, own feature of it. Though the burger is provided by the shop, you are going to add some more features towards it. So you can go and do what? You can go and do overriding. So the literal example is, so overriding says what? In Python, when you have two methods with the same name, each can perform different tasks. Then it is overriding, right? Not only in Python, in general, even the same concept. Overriding, the function kept across different classes has different functionalities. Take it in the other hand like this. In Python, if you have two methods with the same name, function with same name, right? That each perform different tasks, different functionalities. Then it is called an overriding feature. My father have constructed or purchased a land, or my mother have earned some money, or father have earned some money. I don't want to make use of my father's money. I want to earn of my own. The child is incurring the father. Son is inheriting from the father. Okay, so it is showing all the classes across in this program, but let's take any one of them. Land is purchased by the father, money is earned by the father. Son wanted to say, let me use the land from my father. Let me not use my own land. Or I want to use my own land. There is no meaning of then doing inheritance here. If I override everything, here you see overrides the attribute in father, overrides the method in father. My father have earned the land, my father have earned some money. I'm going to say what? I am going to buy a new land. I don't want it to use your money, or I can use your money. Anything the son can say. Here, let's take an example of land I'm going to use from my father. Money I'm going to use of my own, where I have earned 20 lakhs. So now when I go and create an object for this class, when the son is creating an object for his class. Son is constructing a house for 1,500 square feet or whatever on the land provided by his father. So land is coming from where? The father. The class attribute of father is coming, not from the son. You see here, from the father it is coming. The house is coming from where? From the son. And the money is coming from where? You can see here. The money is coming from where? From the son, not from the father, because it is a overridden function. Able to understand? I'm overriding the function in the parent class, because I don't want to use the money earned by my father. I want to earn my own money and construct the house. I have a different functionality applied here. My father is having the amount deposited in the bank plus the interest he earned from the bank. I'm directly getting the amount what I have in my hand cash. But I'm using the same son object, that money function I'm calling. It is returning the amount. But here, it is not a bank amount. Maybe let's assume like this. This is an amount in the bank. This is the amount in the hand. I'm having a liquid cash in the hand. I'm not going to, what to say, withdraw that amount from the bank. I'm going to use from my hand. By calling this function has a different functionality. It is deriving the hand amount. This function is deriving the amount from the bank. Bank withdrawal they are doing. So I want to call this function rather than the other one by overriding. I'm going to say, hey, I don't want to use your function. I want to use my function with the same name. The function with same name, but kept across two different classes. The child class can override the parent class function. That is overriding concept in Python. Very clear, team? What is overriding? The function with same name across different classes has different functionalities. The parent class function can be overridden by the child class. Parent class function can override the child class. This is overriding feature. Where you have found this? Anywhere remember, guys, you found this? The session.py is incurring or it is inheriting from a parent class. What parent class? The Spark session program is inheriting from a parent class called something like a pandas program or a Spark conversion mixin class. So this class says what? My parent is this guy. He's a son, he's the father. The son is telling, hey father, you have created a function called create data frame function, right? I don't want to use that function. You had a function called create data frame. I want to override that. Here it got overridden. Create data frame function here says what? I am using a different functionality. I'm having a different functionality applied here. I don't want to use the same functionality which was provided by you. You see here, this is the functionality implemented by the child class. Let's keep it for our reference. This is the functionality applied in the child class of the Spark session program. The create Spark session class. Now I'm going with another program where I have the mixing program created. Here also, so Spark convert mixing program. In this program also I have a function called create data frame function. The same create data frame function I have. In this mixin program also, I have a same data frame function. So here, they have a different functionality applied, it seems. Let's copy this program. You can find there is a difference between this program and that program. Do you agree? If schema is none, if self-wrapped or conf, arrow, PySpark enabled, or something they are using here, or whereas here they are using a different program. We call it as what concept? So we call this function as what function? The create data frame function we used in the child class called what? This program. We call it as what function? This function is what type of function? Overridden function. Agree? Understood, guys? Understood? When you explain to your kids, use that parent, child, or whatever I used in the simple example. Don't show this program to them. No need to show. No need to open this program even. By yourself, even I'm telling. You don't have to worry about this program. Just I'm showing you how they implemented in the background. What is the purpose of this learning? Right? So it is in the book of learning. We as a data engineer don't implement all this and all, because we are not developing a big framework to be used by the people across the world. Spark is being used by the people or the big companies across the world, where huge money and huge business is being involved. There they are applying all these strategies. When we create these programs, we don't have to bother about all this, but at least once for all, we are taking an opportunity to learn about this. Okay, consider in that way. If you have to use parent class function in the child function, don't use the function with the same name, use a different name. Now you are using what function? If you use a function with the same name, then it will become override. Now he is using what function? Father's program, not the son's program. Maybe I can go and say, I am going to use the money that my father have earned, the money I also have earned. I'm going to mention like this. Now the son can construct the house with the amount what father have earned and he have earned. 10 lakhs, 10,000 plus 20 lakhs. 30 lakhs, 10,000. Done? Got it? Yes. Now Visagan, excellent. Single inheritance. Here also I'm doing a single inheritance, but I'm overriding. Earlier I was overriding. Now I'm just directly using only the feature of single inheritance, no overriding. Clear? Clear, guys? It depends. Okay. Okay, guys, done. I know this is not a simple concepts or it's not, I'm telling it is not much useful as well, but take this as a one-time opportunity. I could say this is a lifetime opportunity. Will you get the same chance of learning this object-oriented programming again in your life? Do you think so? I don't think. No one is ready to teach this, or no one is interested in learning this as well. Because this has to be learned with more cautiousness and more simplicity. If you go with complexity in learning this, why am I using a simple program, simple one-line program? I want to concentrate on the concept rather than functionality. Concept, how it works, we have to concentrate. Okay, take it lightly and go. Right, guys? Okay, let me go forward. What's the next topic? Inheritance, polymorphism. Important topics are covered. What is the next one? 3.1. Either encapsulation or abstraction, anything you can learn. Let us cover the encapsulation. Almost encapsulation and abstraction are same kind of concepts. Okay, let's take it lightly. Okay, for making you understand the concept of encapsulation and abstraction, there is an example I have taken for an understanding purpose. Encapsulation says what? Hiding of the or protecting not hiding, protecting of the functionalities or values. The abstraction says hiding of the functionalities. Very simply say at the very high level. We have to take an example to understand the difference between encapsulation and abstraction. Then once you complete the exercise, you can able to understand all of this very easily. Protecting or controlling the access for the functions or functionalities and the values. Whereas hiding the implementation of the functionalities or forcing to use of the implementation of the functionalities. This is how we can mention abstraction and the encapsulation. Okay, take it lightly and let's go and see. These are all the features of object-oriented programming. 2 more features. So we covered so far what here? Just see this. Inheritance, different types of inheritance. Polymorphism means in general what is a concept? Overriding and overloading concept, Now we are in part of learning encapsulation and abstraction. What is encapsulation? We are going to learn. Or both abstraction and encapsulation we are going to learn together. Okay. Encapsulation means what? Right? You take a calculator as an example, as already I have just got it from an online. Encapsulation says what? Maybe did I have any definition mentioned for encapsulation? Okay. Encapsulation is a method of hiding or restricting the access, right, for certain members defined inside the class. In a formal way, if you call like this. In a casual way, protecting or controlling the access of the functions or values inside the class, maybe, or across the class. Inside or across the classes. That is encapsulation. Specify the access specifier by using notation or by using the term, using the maybe like terminology or what is the syntax. Anyway, you can achieve that. Okay, what is that? We'll go and see. So take an example of a calculator. What is encapsulation? We are first trying to understand. Take a calculator. I'm going to take a different example of car. Let's consider a car. Okay, I'm owning a car because we are taking an example of a car. Always in our real-time example, right? I always talk in terms of the car or bike or something. Let's take an example of a car. The car comprised of the maybe like ignition module. You know about the ignition module of the car. We have key. We have maybe like the security system inside the car, right? You can put the key and switch on the car, it will be started. But the key should match with the internal security system what they are maintaining. There will be some chips and all will be maintained to sync between the key and the car's engine. Yeah, immobilizer. Excellent. They call it as an immobilizer. What is immobilizer says? The engine will be started or mobilized only if you use the same key pair. So they'll use some key pair in the key, which has to be in sync with the device what they have fit called immobilizer or a security system in the engine. So if you want to mobilize the vehicle, right, we have to use the right key. Okay, now I am the owner of the car. I have been given with the key to start the car. But being as a owner of the car, do I know how the security system works? Do I know how to pair this car's engine to get started with my own intelligence applied rather than using the key? I am the owner of the car. I purchased by giving all the amount, but the company says what? Hey, certain things are hidden for you. Certain things are not given to you. You are not allowed to be accessed. You are protected. You are not given with the access to certain features. We use it internally for our own purpose. Internally, we use that immobilizer or whatever the security system concepts. Using the key, when you access, we'll allow you to open. If somebody else coming from the outside world, they don't have even the key to start the engine. Even for you, you need a key to start the engine. To make this engine mobilized, you have to use the key. So there are different levels of security maintained in the car which is owned by you. For my car, I have certain levels of protection in terms of accessing the whatever the devices or whatever the features of that car. So in a class, I have multiple functions created, multiple features created. I have an access control towards that feature. That is the concept of encapsulation. So in order to use a calculator for certain mathematical equation, right? Assume it is a complex function, right? In the end, I want a result out of it. How that calculator is calculating the results, how they are doing that calculation. Some hidden values they may have to provide the result to me, right? Some proprietary things will be there maintained in the calculator to provide the result faster to me. Some performance tuning they might have made. If I write some numbers to the calculator or to a system or to a tab or a mobile phone, they are giving me the result much faster because they have some implementation internally maintained. They don't allow this to be open up for everyone to the outside. When I calculate something in the calculator, it should not show me how it is calculating. It has to give me the result ultimately. Right? Maybe it uses some tricky things internally to calculate some input that I'm giving. That tricky things I don't want it to see, or it don't have to expose that to me. Right? So, for example, you start the car using the key provided by the company. The key will be synced with the immobilizer device in the car to make your car mobilized. We only hold the key, we don't hold the immobilizer. We don't have a control on the immobilizer. Only the key can speak with the immobilizer and get the car ignited. Whereas, so there are different levels of securities are there. Some people can touch the car from the outside, right? Every public people, so let's say what are all the access controls that we can define for a car. Access controls to the car. Right? Let me just take this as an example. Maybe I'm going to rent a car in Uber. Right? I'm going to rent a car. What are the access controls we have? Being as a public who rented a car, we have access up to the maybe like what to say, the front seat, not a driver seat, the front adjacent seat, and the back seat. I have access. And being as a protected member, we call it as a protected, who is nothing but the passenger is public, I could say. The protected is nothing but the driver. Driver is a protected member of the car. Access up to the front driver seat plus steering, all the other devices. He has some access control defined. The company, who is a private member, we can define one more access control called private access control. That is defined by the company, the manufacturer of the car. If you lost your key, right, you have an access to the key, whatever the key used for starting the engine. Access to the everything, the company have access to everything, including the immobilizer. Immobilizer, I can't able to access being as a owner, but the company manufacturer knows how to even mobilize the car without the key even. They have some devices to make that happen. That is more internal. It's not exposed to the outsiders. But being as a member of that car, being as a owner of that car, right? You can able to even go and get the private work done by the company. If you show I am the owner of the car, or I am the person who purchased this car, you can go and ask the manufacturer to say, I want a different spare key. Yeah, I want a different spare key with the immobilizer working. So they will create that and give it to you. They will allow you to access the car if you show your proof of I am a member. So let's try to understand. There are 3 levels of access control we have. Right? Some access control can have only access at the level of what to say, the seat and the front seat and back seat or whatever. Or take a banking example, what we discussed, right? So I just take a banking example. You can go to the lobby, who is a public. You can go to the office room, being as an employee, who is a protected member. Or you can go to the locker room, who is a private member. So through the private member, I can access the locker. I mean, through the maybe like a manager, I can access the locker room, provided if I show my authenticity. Okay, that kind of the encapsulation, the object-oriented programming maintains. Let's go and see this by implementing. So there are 3 levels of access control we have: public, protected, and private. What is this differences? We'll try to understand. Now I have a class created. Let's go with the same type of class. Let's take all these functions and all for now. Later we can implement some functions. Okay, this is a typical program that we created. Now, I'm going to say, hey, make this land as a protected member. So if I put an underscore before the variable, it will become protected. So what it says? Unresolved attribute, land for the class son. It becomes a protected member. So I'm directly trying to access the protected member of the class, right? So though I just got this value taken, but when I create an instance of the class, it is telling the land variable is not accessible. So I'm just going to access it as a protected variable from the outside world. Being as a member of the class, access to the what member of the class? By just putting underscore, it is telling it is a protected member. Because I paid some amount to the Uber driver, to the Uber company, I'm accessing the car. This is a protected member. What is protected? We'll see more in detail, right? Let's wait for it. What are the 3 members? First try to understand, then we can try to understand what are all the significance of all the 3. Basically, we can define the access control by using 3 methodologies. One is public, private, or protected. This says I'm a protected member. Protected member has some level of security applied. Like what I could say, through the member program, since this money or this son is inheriting from the father, he's already the member of this, or he's already a, what to say, like a child class of the parent class. By this way, he have access to this land. So since I am the son of the father, I can access his land. But the father has some locker, some money is kept in the locker he's having. Okay, that money he don't want to expose to the son by now. He wanted to expose it later. Not now. The son does not know whether my father has some money or not. Right? In that case, the father can make that money as a private member. Only if father feels, let me give this money to my son. Right? What he will do? He'll enable this money like this to his son. He can't make this money available to the son directly. So he have to make it as a public member. Then only it can be allowed to be used. Okay, let it be. I'll talk about it. So basically, if I try to access this money, which is a private member of the class, father class, despite I am the son of the father, despite I am a kind of a legitimate user of my father's property, my father don't wanted to expose this outside until some period of time. Maybe he don't want to show to his son saying like he has some money. So what he'll do, he'll make it as a private member, and he used this member only for his purpose. The money will be used by the father for his own purpose. Maybe how much money he have equal to, he'll call this money function. The father can use this money for his own purpose, or let it be. And he'll expose his money to the outside world, maybe if he want. Okay, so now you can see here, basically, the father wanted to say, I don't wanted to expose the money to the outside world, to my son or anybody, right? So what he'll do, he'll make it as a private member by putting underscore, which can be accessed by the son. Even though if I put underscore, it will say what? This particular function is not available, unresolved attribute. We can't able to access the money from the father. The land can be accessed because he is member of the class. So he's accessing the protected member of the class. Public member always can be accessed. Maybe a father has a public member called, maybe some wood in a form of teak wood. He incurred some teak wood, which is a public member, which can be accessed either by the outside world directly or by the members or anybody. There is no doubt in that. Public members can be always accessed. The protected member can be only accessed by the members. For example, if I want to access this public member of wood, anytime I can access by this son object or direct object of the father. So I'm going to create one object called father object. I'm going to access his member. What are the member? The wood I can access. The wood I can print from his desk. Leave this son and all. We'll discuss about the son. Directly, let's take this father example. He have a private member. I mean a public member. I can access that directly by doing this. By creating an object of the father. Let's go to the son object later. Let me not make you confused. We'll go to the son object later. First, let's take the father example alone, and then we can go and include the son. First, go with one class. The father has three attributes. One is a public attribute, protected attribute, and a private attribute. Okay, now In a car, I have 3 types of attributes. How do you define public, private, and protected? With underscore, if I put, it will become protected. If without putting any underscore or nothing in the prefix of the variable name, it will become public. If I put double underscore, it will become what? Private. Okay. That is a notation what we use in our Python programming. In other programming language like Scala, we put public. Sorry, public val x equal to 100. We have to put it inside the class maybe. Okay. I had to create a class to put it. Let it be. So in the other programming language, we have to use this term called public, protected, or private like that. But whereas in Python, we can directly use underscore, double underscore. Double underscore represents it's a private member with the prefix of double underscore. Protected member with the prefix of underscore. Public member by default. This is how it goes. You got it, Naresh? Right, or not Naresh? Who is that? Ram. Right? See here, I'm using underscore or double underscore. If I don't use double underscore, it will become a normal public access control. Okay, now I created an object for this father. I'm accessing the wood directly. The father, whoever has the wood, I'm directly accessing without being even a member. Without even I become a son of the father, I'm accessing the wood what he is kept in the lobby or somewhere. Right? Some wood one of the person is having, I just want to make use of the wood. For creating some fire or whatever. For cooking the food, I want to use that wood, which the father is maintaining. A person is maintaining. This is a public member. Anybody can access. By creating an object for a class, I can access the member. Now I want to access the land created by the father. What it is telling? Access to the protected member of the class. It is protected. Right? Basically in Python, since it is a programming language which has the dynamically typed language feature, it allows even to access the protected member. You see here, we are not supposed to access the protected member of a class without becoming a inherited class. If being as an inherited class, I can access the protected member directly. But Python is weak in the protected member. If you go and see in the internet, Python protected member is weak. Python's conversion to make instance variable protected by adding the prefix single underscore. This efficiency prevents it from being accessed unless within a subclass. What they're telling? If you don't have a subclass created, if you don't have a child class created, these protected variables are not supposed to be allowed to be accessed in a class in general. That is how the protected member is created. But I did not create a subclass. I did not create a son class. See, son class can always access the protected member of a father. Father is telling what? Hey, son, I am protecting this land for you, not for outsiders. I am giving this wood for anybody. Outsiders coming or anybody is coming in, I am giving it. So here the wood says what? I am a public member. Anybody can enter into the car and ride there or take pay some amount and take the car. Like they can sit in the back seat of the car or side seat of the car. But the driver can only access or drive the car. Like this, in general, the things works in every object-oriented programming language in the name of the protected member. The father says what? Hey son, I have created this land for you as a protected member. So only becoming a member of me, only becoming a son of me, you can access this land from me. Like this, in general, it works in any programming language if I have the encapsulation applied at the protected level. But Python is weak in the protected level. Python is weak in protecting the values, right, from are being used by others. That means what? Even if I'm going and accessing this protected member, he's telling a access to the protected member, but he's allowing me to access. He's allowing me to directly invoke this class and make use of this object or make use of this variable. Basically, we are supposed to inherit the class and become a member of this class. Then we have to access that. Only by becoming a child class or only by becoming a, what to say, like a inherited class or a child class or a subclass, I have to access this protected member in general. That is how it works in other programming language like Java or Scala. But whereas Python, the protected member is weak. One second. I'll show you guys. Python is basically weak in providing the protected member access. That is what basically we used to get in Python. So it is not suggested to use this protected member. Let me go here and see whether they have mentioned something related to that. Okay, you can see here the members of the class that are declared protected are only accessible to the class derived from the parent class. Right? Basically what they are telling, by using this underscore, we can protect the variable can be only accessed by the derived class of the student class. You can see here, this is a parent class, this is a child class. Only this guy can access this protected member, the name of the person or whatever is defined here. But what is the problem we are finding here? We are directly accessing this land without even having a child class, which says Python is weak in protecting the values being used from the others. The only drawback what we have in the protected member, but it is very strong in the public member. If I try to access the public member of the class, this money function, if I want to access, I can't able to access at all at any point of time. Money of, if I want to access the money from the father, even being as a member, being as a son of the father, I can't able to access. But being as a common person who invokes this object, the protected member can be accessed, but which is supposed to be only allowed to be accessed by the child class or the derived class. But that is not achievable in Python. The only place where Python is weak is in the protected member. Maybe I'll try to get that reference for you guys and give you to prove that it is true. But I'm not proving through the reference, I'm proving through the program that I'm using here. We are not able to access the money function, unresolved attribute, because father is made it as protected, as private. But if I make it protected, I can able to access. I can even able to even get the money from the father also. I mean the money also I can get it from the father if he is made it as a protected member. But since the father made this money as a private member by using a double underscore, I can't able to access by instantiating the class. And then what is the need of this money? What father can do, if you want to expose this money to the outside world, he can convert this money into a public member, and he can allow me to access the money by using the public member. So this becomes a public member where the money function is called and executed and provided the result to them. That is being stored. This value can be used by outsiders, provided if father wanted to give this value. One second. One second. Let me try with a variable declared. Okay, being as a function, it is not helping me. Let's take it for an example for now. The function wise, I will run and show. Okay, so let's take it for an understanding purpose. I am having a private member inside this class. Let's not go with the function for now. Let's try to understand this concept. I have a public member, protected member, and a private member inside a class called father. Basically, the public member can be accessed directly. When you instantiate the class, you can directly access this public member. The protected member should not be accessed basically when you go and just define a class, or when you instantiate the class as an object. You should not be in a position to access the protected member directly like this. But this is a weaker section of Python. What it says, I will be still allowing you to access despite you are not going to be one of the member. In that case, what I do, I will protect this as a private member. Private member works perfectly in the Python programming. What it says, if you are trying to access the private member from me, I don't allow. Then the private member can be used only by whom? Only by some public member, or only by some other member of this father class only, not even by the derived class, not even by the subclass of this father, or the derived or the child class of this father. Even the child class of this father can't access this money. Son says, I want to access this money from the parent class. It says what? Sorry, you don't have an access for this money. But whereas here I can able to access. Within the father class alone, the private variables can be accessed. So that is what the conclusion. Private member of the with the underscore prefix. And the private member can be only accessed within the or by the other members of the same class. This is the only scope of the private member. If you want to access the private member, only by using the other members. Within this class, how many members we have? Wood, land, money. The other member, money, can access this underscore money. Outside of this, being even as a inherited class of a parent class, you could not able to access this underscore money because it is having a private protection. The father says it is totally within me. So within the company who manufactured the car, they can access this immobilizer module or whatever. So the money can be accessed only by the father by using some other member, or he can take only whatever the money he wanted. Out of 1 lakh 10,000 rupees, he can take, I mean, like 1,000 rupees in his hand and give it to somebody. He don't want to expose this entire amount to somebody. That he can do by creating a public member. He can assign this private member and expose this as a public value by doing some operation on it. You don't have to expose the entire value. So the private member has a significance of saying what can be only accessed within the same class by the other members. Only the members of the same class can be accessing the private members, basically. The public members can be accessed by anybody. Not even it is supposed to be a derived class. It can be any class who can access the public member. And the protected member is supposed to be, in general, the protected members of a class should be only accessed by the derived class or subclass or whatever, or child or whatever. Only the child or derived or subclass can access the protected member. But Python is weak in using the protecting the values. Even it will allow others to access, right? By protecting the values which is being accessed or allowed to be accessed, used by everyone, regardless. Almost the public and private protected has same priority in the Python programming language, especially because it is a dynamically typed language. Because of that reason, Python allows everybody to access this value, even outside also. But basically, how the access control will be maintained? The son will access not even the money, but the son can access the land provided by the father. He can access this land. After I become a son of the father or inherited class of the father, I can access the land, but not the money. Maybe the money, if I want to access, the father has to say, hey, I am going to give you some money alone. I'm going to make it as a public member or a protected member by taking some money from my account. I have a 10,000 in my account, but I'm going to give you only 1,000 to you. You can't be able to use the 10,000 directly from me because I have it made as private. But I open it for a public or not for a public, or I can make it protected. By that way, my child can access. By making it as a protected, what the father is telling, this public can be, the private is converted to protected after doing some operation on it. So the protected member can be accessed by my son. Like this is telling. You can access the protected value, right, by creating an object of the son object. Where is the son object? This is allowed. So in general, the father class can be instantiated directly to access the public members. Public can be accessed by anyone without restriction, without any restriction. In general, protected member should be only accessed by the child class, only by the son class, not directly by creating an object on the father. You should be allowed to access. This is not supposed to happen, but Python is weak in protecting. That is one drawback of Python programming, or not a limitation of a Python programming language. But the private can't be accessed by anyone, even maybe derived class, or by directly by creating an object. No one can access. Private can't be accessed by anyone. Either it's a derived class or a direct object. It can be only accessed by the same class members and can't be accessed by anybody else. Even I'm creating a direct object, I can't able to access the private member. Or even I am a child object, or I'm a child class of a parent class. Even I too can't able to access the money my father is fully holding. I can only access, if I want to access the money from my father, he had to convert that into a protected member or a public member, and he had to provide me. So the private member can be only accessed by other members of the class. That is not possible. So private has a full rights, full priority, full access control. But the protected and public behaves like public in Python. In other languages, the protected will be having the protection only to be accessed by the derived class. Here we are accessing this land even by the public member. Whoever is accessing, creating an object of this class is accessing the protected member, which is not supposed to happen. Public member, no one can access. Even being as a child class or being as a common class or a common object, we can't able to access. This is the access control what we have in Python. So let me summarize very quickly. We have a father class, has three types of, or three scope, or three access controls, access modifiers. We used to call it as an access modifiers. Public is an access modifier, which can be, in general, every value that you create or on function that you create, it's a public, which can be accessed by instantiating this class. By loading this class in the memory, by creating an object, you can access this public members directly. No doubt in that. Or an inherited class can access the public member directly without any doubt, like this. Like this, you can directly access the member of the parent class if it is public. And we can create a member of the parent class as a protected by putting an underscore before that member. The protected member has to be only accessed by the child class in general, in any programming language with respect to the object-oriented programming. But in Python, it is weaker in protecting the values, which can be accessed even by the public member also. Even a normal object that I'm creating on top of this parent class can be accessing this land variable. But it is supposed to be only accessed by the son object, because son is inheriting from the father. He alone should have access for the protected member of the class. But that is not happening in Python programming language. That is a weaker section of Python. But the private member, if I create inside a parent class, which can be accessed even by the son class or by the outside object that I create directly on top of the class, no one can access this private member. Private is very strong in Python, which can be only accessed by the members of the parent father class. Not even by the members of the child class it can be accessed, or not by the direct object creation also we can access the private member. Private member is very strong. So public can be accessed by everyone. Protected should be accessed only by the child, but that is not happening in Python as we expected. Private can be only accessed by the other members of this father class, of the parent class, not even by the child class or not even directly. So private has a strong access control in Python. Protected is weaker in Python. It won't expect as like the other programming language. The protected won't work. Getting me, guys, what I'm saying? With me in this? I know this is a bit tricky to understand, and Python works a bit differently comparing with the other programming language. But that is how the access control works, the encapsulation works in Python. Especially the protected member, we can't depend on it. So we have to create it as either private or public. Private say is very, very strong. Private says what? I will be only accessed within this class, not outside anywhere. But protected, supposed to be accessed only by the child classes, but it is getting accessed even by the common object that we create also, which is a drawback or which is a weaker section of Python. Okay, even can be accessed outside also. I'll get some reference and send it to you across also. I'm not able to get it right now. Okay, any question in this case? You are able to understand this encapsulation concept, hiding off some functionality, some features, and controlling the access to that. Not allowing. See, now without going into this parent class, without having this money accessed by some other member of the parent class, do I know how much money this father has? I can't. Only he can access this money of the private value, and he can expose that money to the outside world as a public member, as a protected member or a public member by performing some operation on it. Not directly he's going to expose. He is going to expose only whatever is needed, how much is needed. That is a feature of the private member. Otherwise, if I have a private member like this, and if I'm not exposing like this, there is no meaning of having a private member here. No one can access this private member. Only this parent class, this class members can access this private method or private value. If I don't access like this, then there is no meaning of creating this private member. It can be only accessed by the members of the same class, not by anybody else. So if I define like this, and if I'm not using it anywhere, it is just a definition. That's it. I'm not using it anywhere. But I'm exposing this to the outside world by converting this into or reducing the access control to one level down and sending it as a protected member or a public member even. You can remove this to make it as a public member. But you are not exposing the entire money. You are exposing only some portion of amount. 1,000 rupees you are exposing, not all the 10,000. With me, guys? You got the concept of encapsulation, right? Abstraction. Let me just close with abstraction. Maybe okay, we'll discuss now abstraction, and we'll close in another 10 minutes. By 12:30, we'll go for a break. Okay, abstraction. Abstraction is a concept of hiding the or forcing to use some of the implementation or hiding some of the functionality or hiding of functionality or forcing of the use of some functionality. For example, the same calculator program you take as an example, the encapsulation says what? A certain thing we are hiding inside. We are not allowing you to access. We are internally accessing it and providing you the final result what you want. That is what encapsulation says. Certain things will allow you to directly access. Anybody can access. Certain things only the members can access. Certain things only within the class I can access. Not the inherited class can access. Only the members of the given class can access. Certain things the public users can access. Certain things the owner can access. Certain things the manufacturer can access. That is the access control what is defined in the name of public, protected, or private in the maybe like encapsulation concept. But abstraction says what? When you are going to use the calculator, right? The power source that is providing you the maybe like power to the calculator must be used. Without switching on the calculator, we can't use the calculator at all. But the power is coming from the solar panel or from a battery or from a charger. You don't have to maybe like bother about. Or I will have an abstraction created on top of that to say you have to use the power button or you have to use the power for the calculator, but what are the way the power is coming that you can define. So for example, a company is going to manufacture some product. In that product, they will be having mandatorily certain functionality has to be used. But as per the custom requirement, it has to be used. For example, let's take a TV example, or let's take even a car example. Okay, again the same car example. Let's take a car has power feature either by using the key entry or keyless entry. We know these two methodology we can use. Keyless entry we can do, or keyful entry we can do, right? We can our entry or our keyless start by pressing the button. We can press the button or key entry start of a car. Okay, this is a feature what we have, which is supposed to be used by everybody. Whenever you go inside a car, you have to start the car to achieve all the other features. But my parent class that I'm going to create says what? Irfan, I'll give you a function called ignition function in a class. But that ignition function, I don't have any implementation made. I'll only have the feature called ignition enabled in the class. But when the child class is inheriting this feature, they have to implement it. So basically what abstraction says, the features are hidden or not implemented, which is forced to implement later as per the requirement. Let's see this example, you will get to know about it. Okay. A company is going to manufacture a car. Okay. Or common features of the car, it is going to apply. There is a class called common features. What are the common features of a car? Maybe let's take two functions as an example. The common features such as ignition feature is one feature what we have. In the ignition feature, I'm going to say I'm not implementing any feature in it. And I'm going to have one more function called maybe like what to say, music feature. Let's have that music feature itself, the music system feature, where I'm going to allow the people to use some button like such as volume control button or mode button, mode as FM or whatever. So if so with the existing volume, I'm going to add some volume and send it across as a response. Okay, I have two functions in a common features class, guys. Okay, one feature is ignition feature, another one is a music feature. In the ignition side, music, I have the implementation. I know what has to be implemented, but in the ignition side, I don't know what type of ignition for a different car they are going to use. For example, I have a child class called something like Alto. Maruti Alto car I'm going to manufacture. What I will do, I will go and use the function ignition or not. Maybe I'm going to have a function called what to say, the power steering. Okay, where I'm going to implement some power steering feature. and this car is using the power steering feature, and this car is going to use the music feature. So I'm going to maybe like inherit these properties, common features properties. Now, this Alto car is being sold outside for the customer use. So customer is going to make use of creating an object 1 equal to Alto object there he's creating. He's going to instantiate this Alto car. Now, what are the functions this Alto object has? It has the function of power steering. It has a function of music. But very important function, what he need to have predominantly? The ignition feature. Now, I'm going to sit and start the car to use the power steering, and I'm going to play the music also. Okay. One problem what we had here is, because of the I did not included the abstraction yet. We are still yet to apply the abstraction feature, the abstract class or abstract method feature. We are yet to implement, but let's take lightly. I'm going to apply this abstraction feature soon. This here it is not implemented. If I don't implement an abstract feature, if I don't have the concept of abstraction, then there is a major flaw in the in this system. What is that? I don't have a power button, or I mean, either I have to put the key and start, or I have to have a button to start the car, but that is not implemented yet. That is having a pass over here. Why the common feature is not implementing this function? No implementation. No implementation of features for the purpose of, because we need customization. We need customization. For the reason this common features class is not implementing any logic in this ignition class. So what is going to happen in this ignition function? What is going to happen now when I run this program? Right? Okay, abstraction, right? So last program. When you run this program, it is printing ignition as none, power steering as true, the music, let me pass some argument to this music, right? Mode is MP3, FM, and volume I'm going to raise to 5 levels higher. Okay, now let's run this. So I got an FM started with a volume of 5 levels increased, but the car ignition is not happening. I'm having all the implementation. Power steering is working, and the music system is going to work, but the ignition is not going to be working. I don't have an option to ignite the car. It's a major flaw in the manufacturing. In order to forcefully apply some functionality, this ignition function is mandatory, right? Whether you are going to enable the music function or not doesn't matter. Whether you are not going to have a music system in a car, fine, customer can buy and put it. But the ignition feature we have to implement, right? But we are missing that here. The child function is telling, I don't have a music function implemented, the ignition feature implemented. Basically, what he is supposed to do, he have to go and have a function created for ignition, because the Alto car manufacturer told, hey, I want to build my own ignition feature by saying what? To save the cost, I'm going to have return the keyful entry or key entry I'm going to create. Whereas another class is going to say, I'm having a cruise feature, maybe XUV is another manufacturer. Maruti, I mean Mahindra XUV is telling. Or you have Ertiga. Well, let's go with same type Maruti company. Ertiga says, I have power steering feature. I have other features such as cruise feature, and I am going to implement the ignition as what type? The button start, keyless entry or button start I'm going to do. So this feature has to be implemented by this both child classes. If I don't implement this feature, there is no meaning of having this total implementation made, right? Do you agree? But am I forcefully doing that? Am I asking the Alto or the Ertiga class to implement this feature for sure? Am I forcefully doing this? This is forcelessly. No forceful implementation. If some company implements, some company does not implement. Let's go in this way. I'm going to say, don't implement this. What happens? Now for the Alto car will not have the ignition feature. Alto car is a failure then. Whereas for the Ertiga we have ignition feature. Let me call now. You can see Alto does not have a feature for starting the car, but Ertiga has the feature for starting the car. Either button or whatever the ignition methodology you use. Some methodology you have to use. Alto says what? I don't have any feature implemented. Ignition feature is not implemented in my class. What happens? That leads to a failure. Now I want to say, hey, no, Alto or any other cars who are all using this common feature class, any classes are going to inherit me. The parent class is going to say, you have to use this function for sure. You have to implement this function for sure because I did not implement it. A literal example is, father is buying a land. He is going to give that land to his son and daughter. He's going to say, if you don't use my land, I don't give it to you. You have to use it for sure. The father is going to say. Do you agree? The father is having a land created. Let's assume this is a land owned by the father. If this land is not going to be used by the childs, who is going to inherit that father? Right? Then this land will become waste. The father will be feeling like, hey, I just created a land for you, but you are not using it. If the father have to make the sons or daughters to forcefully use that, then the father have to make this kind of attributes or the functions as an abstract method or an abstract values. The abstraction has to be implemented. If I don't implement abstraction, what happens? The Maruti car manufacturing is a failure. Alto manufacturing is a failure one. Do you agree? I'm not having an ignition feature provided, but I'm going to maybe like sell the car. Major drawback, what I'm going to get. The product is going to be a failure. To manage the situation, what I do, I will go and say, hey, convert this class into an abstract class by following three methodologies. Or add abstraction to overcome this difficulty. What is this difficulty? Let me talk about it. Add abstraction towards this program to overcome the problem of not implementing the parent class functions by the child class. I'm going to say, hey, I purchased a land for you. You take that land and construct some house on top of it. If you don't use it, it is a waste of effort. So the same way, the parent class says what? I just opened it for you to put your own implementation. But if you are not going to implement this, if you are not going to use this ignition function in your program, in your class, then it is a big failure of our design. So obviously you have to use this ignition function in your program to do that forceful implementation. To make my child class to use the function what I did not implemented has to be implemented by him. By adding some functionality in it, I'm going to add abstraction feature towards it. Add an abstraction feature towards this parent class to forcefully make my child uses the unimplemented functions of me. Tricky thing. Let's try to understand. From the program called ABC. ABC means what? Not just ABC XYZ what I say. ABC means abstract class program. It is a module present which provide you an opportunity to include abstraction feature. If you want to include, you have to go and include a module called abstract class, which is not by default available. You have to go and pull that abstract class from the Python environment, Python library. Import some of the classes. First, we have to convert this class into an abstract class. Then we have to convert this method into an abstract method. Then only this method will be implemented by the child class, will be forcefully implemented by the child class. If I create a child class without implementing that function, I will not allow him to use my function. I will not allow him to inherit me even. The father will say, if you don't construct a house on top of my land, I purchased a vacant land. If you don't construct a house on top of that, then I don't give you that land. I don't allow you to inherit the property from me. Other properties even I don't allow you to inherit. Even the music system or nothing I'll allow you to inherit. I'll fail you. I'll make you fail. Like this he'll say. Whether music system you are going to implement in your car or not, I don't bother. Maybe let's say the music system is not being implemented by Alto, but the music system is being used by the other program, the Ertiga. Fine, I don't bother. But ignition has to be implemented by the Alto. So let's go and see. From ABC, import abstract class and abstract method. These two programs I had to import from a module called ABC module. Somebody have created, the Python developers have created this module called ABC module, where I have a function called abstract method function. And there is one more program called ABC class I have here. You have a class called ABC class. They created these two programs. They have a lot of programs. I'm importing only what program I want. So the class that provides a standard way to create an abstract class using inheritance. I have to import these two programs, abstract method and the abstract class. That is what I'm doing here. So let me go and convert this program into an abstract class program, not a normal program. Where is it? I'm going to convert this program, this class into an abstract class by doing what? By inheriting abstract class ABC. So now this class becomes an abstract class. It's not a normal class. It is an abstract class. Now this function is going to become what type of function? Abstract function. Now, without implementing this class, if the Alto says, I'm going to inherit my parent class called common features. If I don't implement this ignition class, right? If I don't define this ignition class and put some functionality on it, the program will fail. I will not be allowed to use that program. Now it says what? Can't instantiate the abstract class Alto with the abstract method in ignition. So Alto, you are my child class. I don't allow you to get instantiated without implementing this ignition function. Now what is forcefully applied here? Without a power button in the calculator, can you operate the calculator? But the calculator manufacturer says what? Hey, power button, let it be developed by using the solar power or by using the power inlet or by using the battery source. I don't bother. But power button is must needed. Power is must needed for switching on the calculator. Then only you can use all other functions. So this function is told by saying what? This function becomes an abstract function to say what? Convert by putting at the rate of abstract method, convert the ignition function to abstract method I'm doing. When I convert this ignition function to abstract method, what it says? Which says all the child classes has to implement this method. That means what? I am having it open. You can apply the ignition by the way of putting the key or by the way of pressing the button. That implementation, when you manufacture the Ertiga car or the Alto car, you apply. But you have to forcefully use a function called ignition function in your car. What are the other functions must be used in a car, guys, for sure. Without having this functionality, I can't make use of my car. some other functionality. Leave this music. Music is a optional functionality. Some other functionality. I have to make it abstract. When do I do? Airbag is optional. Not every car has. Okay. Engine. Let's say engine. Engine is a function which has to be an abstract function. Do you agree or not? Engine is a function. Let's take two functions. Engine. So without having an engine implemented here, maybe Alto is telling, I'm going to have a K10 engine implementation. I'm having a Alto K10 engine. And Ertiga says, I'm not mentioning my engine. I'm not manufacturing my car with engine. But Ertiga is going to fail, saying like, hey, sorry, without an engine method, Ertiga, you can't be available for the consumer use. So you have to implement the engine module or engine function in your program. This represents what? The concept of abstraction. Not so easy, I agree. But this is how the abstraction is being implemented. Abstract method, forceful implementation of certain unimplemented method in the parent class, which has to be implemented by the child class. That is abstraction. Why it is been happening? Why the parent class is not implementing? Ertiga wanted to create an engine with Kappa model, Kappa engine model. Alto wanted a K10 engine model, or Alto wanted some other engine model to be used. So if I forcefully implement that engine model here, I'm asking everybody to use the same engine. But the child class has a priority to create their own engine. But they have to create an engine. There is a difference between the abstract method and the normal method. The normal method I'm creating with implementation can be used by the child class or not, I don't bother. Whether I may use an music or not, that is up to my need. But ignition, the engine and all must be implemented. If I don't get it implemented, what happens? Even I'm not using that engine here, just I'm telling, the engine ignition, when I do, the engine will be ignited. Whether I use it or not in the Ertiga, whether I'm using that engine or not, but it must be implemented here. It has to be an engine mentioned here. Then only this car will be allowed to be used. Now, no errors we are finding. We are good. Engine is K10 engine. Key full entry I'm doing in the Alto car. K10 engine I'm using. I'm having the power steering true. Right? I'm not using the music system. Clear, guys, or not? So what abstraction says? In a calculator, I need a power module. But the power module is not implemented. It is given open for us. When you buy a calculator, it can be used as a solar calculator, or we can use a power inlet charger we can put, and you can switch on the calculator, or we can use a battery power as an input source. But power button must be needed. Power must be needed to switch on the calculator. Power will be given. Power button will be given by the company. The implementation of the power button you have to do, but for sure. Without that, we can't switch on the calculator. That is abstraction says. So what I'm doing here, I'm just going to override. Yes, true. Right, Rajkumar? Yes, I'm going to do, but I have to override. So forceful implementation with the inclusion of abstraction. I'm not overriding whatever the maybe like the functionality already applied. I'm going to create the functionality now only, but must be created functionality. So what are all I'm adding here? I'm adding an abstract class. I'm passing an abstract class as an argument to the main class. Then I'm converting the function as an abstract function by using some concept called decorator. What is decorator? I'll talk with you guys. Wait for a while. And I'm going with the implementation of the function over here in the derived class. So derived class has to implement the unimplemented parent class functions if forcefully Forcefully, the derived class has to implement the parent class functions if the parent class has abstract method, or very simply say all unimplemented abstract methods of the parent class has to be implemented by the child classes, which is the concept of abstraction. With me? Now you go back and see this quickly, right? Power button is needed in the calculator, but the power source can be anything. We don't have to worry about how the power source is coming with. Power source can be anything, but the power button is needed. The calculator manufacturer says the power button will be provided by us. You give the power source to the power button to be anyway. That is open to you. But you have to use any one of the source to switch on the calculator. That is abstraction. Some question? My understanding, if it not forcefully implementing abstraction, then this both will behave like a override. Yes. Yes. If we have some implementation made means, right? However, we are using overriding concept to achieve this, but we are overriding an unimplemented program. That is very important. If we already have somebody implemented something, we don't have to worry about anything. We don't have to make it even as an abstract class. But what we are doing, since it is not implemented, then obviously I have to abstract it. I have to make it as an abstraction to implement by the child classes. Otherwise, it will become unused. And otherwise, this program will become a failure, right? Tricky, guys. I know that, right? But however, these two features you can add in your OOPS learning. Overall, 4 features. With me? Oops, you got some idea, guys. Right? Okay. So we'll go for a break, come back and start with Spark. I want to jump into Spark. I have some more features to be applied in Python, PySpark, or in Python. You remind me, maybe we can discuss about that topic also, something called different class methods. Okay. And then we can discuss about maybe something called a concept called decorator. These 2 concepts we'll discuss. Okay. Different class method means what Payush is mentioning. Static method, instance method. We know already instance method. Okay. We don't have to worry about that. Class method. All are maybe like simple concepts. Don't have to worry too much. Maybe after the break, I'll cover that also. And then we can go to Spark. Okay. Why we have to hold this, right? Let's go and cover this part also very quickly after the break. And then we can go towards Spark. I'll cover this part after the break. Okay. This part alone. Very simple concepts. Quickly, I'll cover this and we'll go to the next
Sir,
part.
the PyCharm is not getting installed in my VM. Yesterday you have.
Yes, yes, Pawan. I was giving you some input and you tried that, and
Yes,
I
sir.
told you by the near ending of the session we'll see that. Don't worry. I remember. Okay.
Okay.
Okay. Yeah. So 12:58 p.m. we resume back. Okay, guys. Hi team, I'm back. So let's quickly cover these two topics, guys. Very direct topic, okay? If you see here, we already used that feature, right? But without knowing what is it. I told something called, we can add abstract method here. What it says? It says, we are converting this regular function to an abstract function. This is not a regular function going forward, it is an abstract function. If we have it as a regular function, whether it is implemented or not in the child classes, I still allow to continue. This program will be still allowed to be continued by Python. It is allowing us to define this child class without having a forceful implementation of the abstract method. But whereas in the case of abstract method conversion that I'm doing with the help of the concept called what? Decorator in Python, I'm able to forcefully apply this functionality of these functions by the child class. So how it is being achieved with the help of a conversion of a given function to an abstract function. What is this ampersand abstract method says is, or what is this ampersand says is, yesterday somebody asked this question, what is this ampersand? It says what? I'm going to decorate this function. I'm going to decorate this function. We are talking about abstraction. Leave that abstraction part now. Let's talk in common. Let's talk in general. I'm going to create one function here. Okay. Func def f1 or def maybe like something called f1 or sal bonus calculation function, which we already know, with the input of salary and the bonus passed. And I'm going to get the response of salary plus bonus. This is a function I'm generally creating. So if we call this function with salary 10,000 passed and bonus of 1,000 passed, it will return me 11,000. This is a common function that I created. Now I'm going to decorate this function. I'm going to convert the salary bonus calculation function to salary bonus and the incentive calculation function. What I can do for that? I can go and simply say a function. Normally you can do only salary and bonus calculation. Why not you can have some more decoration done on top of it? Why not you can be decorated? Like this, what I do, I'll create one decorator function. Sal bond incentive decorator. Like this, I'm creating one decorator function. I'm going to pass this function to this decorator function to get decorated, to get extended, to get added with more features. Like how the abstract method says, I am a decorator of engine function. I'm going to decorate this engine function as what function? I'm going to convert or I'm going to decorate the ignition function to abstract function. The ignition method is converted to abstract method by adding a decorator. Anything that you mention with ampersand, some function name, we call it as a decorator. So you see, a decorator indicating abstract methods. This abstract method will be used as a decorator to decorate our given function. I'm telling you, normally this is a normal function. I want to convert this or decorate it into an abstract function by calling an abstract method, putting ampersand on top of it, on top of this function will be decorated or converted to abstract method. How we can achieve this in general to understand this concept? Basically, the decorators are already created and kept ready in the Python libraries. We are not going to create these decorator functions and all until and otherwise if it is needed. We are already going to use the decorator functions. But to understand the concept of decorator, rather than saying, guys, this function you pass to this function, it will get decorated and return back as an abstract function. So if I don't have an implementation for this abstract function in the child class, the class will not be allowing you to create. Like this, if I say, you'll ask Irfan, how this abstract method is created? It is one another method as like a regular method that we create. It takes a method as an input argument and return the converted method or a decorated method as an output. So this method is a decorator method, behaves like an abstract method or whatever, is going to take the function as an argument. What function? Any function you can pass. And that function is going to be executed, or that function is going to be returned back by adding some more functionality. Maybe I'm going to create a function 2 equal to function 1 of whatever the argument that I'm going to pass, right? A comma B that I'm going to pass. I'm going to pass this function with some arguments. That arguments, it is going to be executed and get a function 2 or a value created out of that, the result created out of that, which is going to be used inside a function 3. Like maybe we are complicating by doing this, but let it be. Function 2 I'm going to create by passing this result as an argument or whatever, or just returning the function 2. By saying what? Let me do like this. Let's not complicate. Let's do like this. Function 1 I'm going to pass, comma, the incentive I'm going to pass. So I'm going to have a function created called sal bonus function. The sal bonus function I can directly call to get the bonus applied salary. Now I'm going to pass this sal bonus function, or I'm going to create the sal bonus function as a decorator function, or passing to the decorator. I'm going to say what, hey, the sal bonus function, what I'm going to create, right? I don't want to create it directly. I want to get it decorated. So I'll say what ampersand, the decorator function I'll create, I'll mention, and I'll say you pass this sal bonus function as an argument to this function. Yes, higher order function. Basically, higher order function we are using to leverage this. We are creating a decorated function by using the higher order function. Yes, higher order function feature helps here. Like how we used the override function to achieve whatever this abstraction and all, right? The same kind of concepts. All are interrelated. So now I'm going to say what? Let me create a function, not as a direct function, as a decorator function. Let me get it decorated. So what happens now? This function will be passed as an argument to this function and get decorated. Get decorated by doing what? This function will be passed as an argument to this function, and that function the additional variable will be passed. Then this function will be executed with all these values and produce the result of this function itself will be returned back. That return function I can go and call by passing the incentive value to get the result. So now I'm going to call this function. Okay, let me do one thing like this. Okay, so here I did not added anything, just I'm returning back. But basically what we do, when this function is being passed as an argument to this salary bonus decorator function, right? What I can do, I can add some functionality on top of this function. I can get this function executed inside, get some result achieved, or I can add some more features to this function, redefine this function. Maybe like I can do in that way, that is more meaningful. I can redefine this function. Whatever is getting passed to me, I can get it redefined by saying def f1 of so basically I'm doing what? Salary plus bonus calculation, or A plus B I'm trying to do. Okay. Now I'm going to say convert this function not to do A plus B, convert this function to do A into B. After I pass this, for example, if I use this bonus direct function like this, if I call this directly, this function will give me sal plus bonus. I'll get 1010. But if I go and call this function by decorating it, after adding it in a decorator, this functionality will be changing. Despite I have the same functionality of return of sal plus bonus writing, this decorator is taking this function as an input, converting this function, redefining this function to do multiplication, not addition. So what it's going to do, if I call the same function, it is going to return me the multiplied result. This is what I was trying to show, but maybe some of the arguments that I used and all is not proper. You see here, just consider this 3 functionalities, right? I'm having a decorator creator. The decorator is, the work is what? Decorating a given function. If I pass a given function to the decorator, what it will do? It will go and decorate that function. Whatever the function that I'm passing, it will decorate that, convert that, or decorate that in the format what I wanted and return back to me. Now what happened? After I send this function to this decorator function, he returned back that function to me in a decorated fashion. So I gave a function to perform salary plus bonus operation to this decorator. The decorator converted this function into salary into bonus calculation, right? By doing some operation here. It is taking the function input as an argument, then it is redefining this function, is decorating that function, changing that function. So when I pass a normal function to a abstract function, abstract method function, abstract method decorator function, it is converting this regular function to an abstract function and returning back. That is what we are doing here also. We are passing a normal salary and bonus calculation function. It is this decorator function, when I add, what it is going to do, it is going to convert that function into other type. A sal bon is passed as an argument. Like it is equivalent to what, you know? It is equivalent to you are passing this function here like this. It is equivalent to you are passing this sal bon function as an argument like this. Not exactly, but you can relate like that way. So now you can go and call this function, store this one in F3 or whatever. That is what I was trying to do earlier. F3 of if I call. Right, it is doing what activity here? It is multiplying these 2 values and returning me. If I call only sal and bonus directly, it will give me the addition of these 2. See, since the sal bonus is defined as a decorator function, it is returning me like that. So the concept is pretty direct. I'm having a function created. This function I want to convert into something else. There are a lot of built-in decorators are created. We created just an example decorator. This function is a normal function which does a salary plus bonus calculation. If I pass 1,000 rupees salary and 10 rupees bonus, if I pass, it will give me 1,010 as a result. But if I go and decorate this, when I define this function, if I say, hey, don't get defined directly, get decorated, get converted by passing to another function. This is a decorator function which is created by Python in different numbers, different decorator function Python provides. What I am telling, I want to define my function by decorating. So what is happening? This function is getting decorated as per this decorator function what I returned. So now the decorated function is returned to me. I'm going to call the decorated function, not my actual function. Actual function, when I call without decoration, it will return me 1,000 into 10, 1,000 plus 10. Now it is going to return me 1,000 into 10 because it got decorated. Following me? So there are some functions created as a decorated functions by Python itself, by the Python developers itself. They call them as a decorator function. You see here, they are calling it as a decorator function. What they help us do is, they'll help us pass some function to the decorated function and convert the given function to the decorated function. Now the function of ignition, we got it converted to what type of function? By sending it to the abstract method. This ignition method is decorated to abstract method. That is the decoration concept, the decorator concept in Python. Are you with me? Are you with me in this case? Pretty direct thing. Don't get confused in the way how I wrote. No one will write this decoration. No one will write their own decoration and all. But what I am doing is, maybe let's take an example. The same example, if you don't feel more meaningful, let me make it as more meaningful example. I'm going to use one function, sal-bon function or whatever, or I'm going to use this function called salary bonus addition or salary penalty reduction. Anything it may be. This function can work in both ways. So if I'm going to call this function directly by passing the salary, first argument as a salary and second argument as something else, maybe whatever the bonus, or it could be a penalty also. If I send salary and bonus directly, if I call this function directly, It will behave like a salary plus bonus function. It will return me salary and the bonus. Salary plus bonus, it will return me. But I made some mistake. I just taken some loss of pay. Let's assume I'm having a loss of pay. So I'll create a decorator function called loss of pay function, or loss of pay decorator function I'll create and say what, hey, you don't go and return something like this. I'll say decorate the normal function. I'll say something like this. Decorate the function to loss of pay function. Like this I'm doing. So this Salbone LOP converter or LOP decorator, I'm calling this function as an LOP decorator, loss of pay decorator. I'm going to convert the Salbone function to a loss of pay function. In the loss of pay, what I'll do, I'll go and convert this function into a loss of pay function. The loss of pay, what I'll do, I'll go and do subtraction of the salary and the bonus. So the function whatever is passed to me, I'll take that function, convert that into a loss of pay function and return the loss of pay function to the calling environment. If you decorate this function. So directly if I use this function, it is going to calculate the bonus. If I decorate it by passing to the Salbone LOP decorator function, if I pass to this function, then what it will say, I'm going to convert this function or decorated this function to the loss of pay function. This function is decorated as a loss of pay function now. Now when you call the same function with the same argument, it is going to do what? It is going to reduce 1,000 rupees from my salary and return back only 9,000 rupees, not 11,000 rupees. So a normal function what we created here is directly used, or it is being converted or decorated as an abstract method and used. That is called decorator in Python. With me or not, guys? Take this as an example to understand. What is decorator in Python? A normal function. This is not a decorated function. Calculate salary and the bonus. But where is the decorator function? I'm creating a separate function. Whenever it is our given function has to be decorated, I'll use this functionality. Otherwise, I don't use. So I'm defining the function now as a decorated function. Does loss of pay calculation. This is how the decorator works in Python. Normal function I'm calling. After I decorated, it becomes decorated function. It changed this characteristics. Done, guys. What is decorator? You got it. There are different types of methods available in Python. Decorator is a concept of converting or decorating a given function using @ decorator function prefix in the top of the function. Okay. What is the next topic of discussion is, maybe you can say these are all the 11th and 12th topic, okay? 11th topic and the 12th topic. Different class methods. Different types of methods that can be created inside the class. What are all those? So we know about the instance method. Directly when I create a class, INS class, instance method class, I'm going to name it as instance method class of RR colon. I'm going to have a class created with def init function. Maybe I can pass some parameters. Don't have to pass some parameters, nothing. Maybe I can maybe like have it like a normal function created and a class attribute self dot attribute 1. I'm going to create with a value of something. Then I'm going to have a function created, regular function created. Maybe like add function I'm going to create. Take some input. That's it. I'm going to create an instance of this class. So what is an instance method says first? This is instance method. What we so far learned. The method called instance method only we so far learned. What it says, when you have a class created, you have to instantiate, you have to create an object for that class to access the members of the class. You have to create an object. Otherwise, you can't be able to access the members of the class. That is what, in general, the instance method says. So print of obj1 dot add function. This is how I have to access the members of the class. If I have to first instantiate the class to access the members of the class. We use self keyword to pass the class instance, right? And then access the members of the class by that way. This is a common way what we used so far in our learning. We call it as an instance method in general. We don't name it separately as an instance method and all, but this behaves like an instance method. Instance method says what? If you want to access the members of the class or a general or a common type of methods, we create in Python. We create in Python. This is the 99% we create the functions like this, methods like this in Python. That is instance method. What it says, I have put some of the maybe like properties of the instance method. The instance method has to be should not be using any decorators. The instance method has to be accessed by through the object creation. The instance method maybe like access all the members of the class, other attributes of the class by using the self keyword. Like I have given the pointers for that over here. The conclusion of what is instance method, class method, and the what are the I mean like static method. Maybe we will use this conclusion later, just for your maybe like reference. The instance method says what? No decorator needed. What is decorator not needed? We'll understand in the next point. Instance method says I can be accessed using the object of the class created, right? That represents what? This method will be accessed only at the time when the class is instantiated. This instance method will be only accessed at the time when the class is instantiated. And instance method can access all the member variables of the class. Like these are all the member variable, right? The attribute 1 or whatever. This is the property of the instance method. Let's talk about the other methods. You'll get better clarity. I'm going to create another method called class method. Class method class I'm creating. The class method says what? Some properties it has. We have 3 types of methods that can be created inside a class in Python. Instance method is one what we generally create. There is no question in this. Directly we know about this. So far we are learning like this. But there is a special type of classes available in Python. We call it as a class method. What is class method? Not a common type of method available in Python. Basically, the class method says what? The instance method says what? The name itself says common method available in Python requires instantiation of a class to access its members. What does it mean? We have to always create an object. Instantiation means what? Need to have an object created for accessing the members of the class. Do you agree? This is needed. Directly we can't say, hey, go and access the member of this class called addition by directly using the class method. It will fail. It will not allow me to access. It is telling what? A, B, C and all are unfulfilled. If I go and mention self as 10, A as 100, B as 200, something like this, if I call, it throws an error. It won't allow me. What is this? I can't allow you to do this. It will get failed. So we can't be able to do this without creating an object. The instance method says what? Irfan, if you want to access this method, you have to instantiate the class. That's the reason they are calling it as an instance method. In the other hand, there is a class method we have. What the class method says, Irfan, you want to access the members of the class, the attributes of the class. You have to have a class attribute created for that. If you want to access the class attribute, you can access still. But you don't want to instantiate this class. You don't want to load this class in the memory. You don't want to create an object for this class. You want to directly access the members of the class by doing this. Without creating an object, I want to access the members of the class. Without instantiating, without creating an instance of the class. I want to access the class members. We have to use what type of method? Class method. Then use class method type or class method in Python. You want to say like how Banu was telling yesterday, Irfan, I found somewhere no one is using or somebody are not using the object creation and all. They're not creating object and all. They're directly doing what? They're creating a class. They're accessing the class members without creating an object. In order to do that, what you're supposed to do, the attributes of the class can be directly accessed like this. If I create this class, it can be accessed directly. I don't have to create an object. I can directly access this class method by calling like this. .attr1. But the method, if I want to access like that, what I'm supposed to do, I have to convert this method into what type of method? The class method. I have to use a what here? What I'm using here? I'm using a what here, guys? We call it as what here? Ampersand at the rate of something I mentioned means what is this called as? Decorator. Python will instantiate it automatically. Yes, Naresh, true. True. This is a default constructor, what it uses. But whereas if I have to go and access this method, I have to convert this method as a class method. For variable, for the attribute access, it can access directly by creating a constructor. Even here also we can access. But here what it says, the method, the add method is converted to what? Or decorated as? Or converted to what type of function? To class method, which does not require what? Object creation. No need of instance. Does not require an object instantiation or instance. Directly I can go and access this class, this method without having any hurdles. This time it is going to work. But what it says, one thing it expects me to mention. Saying what, Irfan? You mentioned this method as a class method. So don't use the self keyword. Use CLS keyword rather. We learned about self so far. Now what it is telling, Irfan, since you changed this method as a class method, don't use the self keyword. Please use CLS keyword. CLS keyword to access the class attributes. Don't use the self keyword. Now you can see properly it is not giving any suggestion to me. If you use self keyword, it is telling, no, don't use self keyword, Irfan. Usually the first parameter for such method means what? Class method is CLS, not what? Self. So far I suggested you to use self. Here if I use CLS, what it says? No, don't use CLS, Irfan, because this is a instance method. Use self as an argument. Depends upon the decorator you did to differentiate. This is not a normal method. This is a class method. You have to pass it as a CLS, not as a self. So you can see somewhere in our library, they might have used this CLS. So you can see somewhere they're using the CLS as an argument. So these functions and all created as what type of function? What type of function they created this and all? As what method they created? Class method. They decorated it as a class method. They want to access the attributes of the class without getting instantiated. So this get or create function, what we are going to learn next in Python in Spark, we use this get or create heavily. This get or create we use in our Spark program heavily. Whenever we write this as a first line in our Spark program, the get or create function, we call it as a first line in the program. What it says, Irfan, I'm going to call this function without having the class instantiated. You don't have to instantiate this class. This program will work 100% perfectly without asking me to instantiate this class. Now you see, I did not instantiate the class. Do you agree? I'm mentioning the class name dot function name of arguments. Do you agree or not? I'm not creating an object for this class, but still it works. Because of I'm creating what type of method here? I'm telling, hey, method, don't wait for the class to be loaded in the memory. You allow to directly access the class dot method without getting this class instantiated as an object. Even if you want to go in a traditional way, no, I want to create an object for this class. I want to load this class in the memory. Then I want to access the function by using object dot class name. Do that also. It supports both. Now I want to go in a formal, in a traditional way. Despite it is a class method, I want to access it like an instance method. Yes, you can do. But you don't have to always create an object to access a class method. That is what the class method says. Very direct. Don't create an object to access the method of the class. Directly access it. It's not common type. Some special type. Functions or methods in Python. Right? Needs @ class method decorator. But particularly, what is the concept behind it? No need of creating instance of a class. That means what? No need of creating objects in general. To access the members of the class. The class take the argument of the class, not the object. It takes the direct class as an argument, not an object. Self is an object reference. Class is a class reference. CLS itself says it's a class reference. So what it does basically, without instantiating the class in the memory, this function will be separately loaded or invoked if you define it as a class method. So in this class method, we can have multiple methods. Even we can have a normal method created. So addition I'm creating as a class method. Subtraction I'm creating it as a normal method. So subtraction requires what? You have to use a self keyword. Subtraction requires subtraction I'm creating as what? A normal method. A minus B. So here you can go and have a subtraction method called by instantiating the class and the class method called by without instantiating the class. Got you? I mean, got me? The third type. What is the third type of method? I was talking about it yesterday even. Something called static method. Special type of method in Python. No need of creating an object for creating an instance of the class to access the members of the class. Need of static method as a decorator. Then what is the difference? The only difference between the static method and the class method is class method and static method looks similar. Only difference between class and static method is static method can't access the members of the class. What is the difference? I told an example. In a bank, you have a tea shop. The tea shop owner can't go inside the bank office and access the bank document or anything. Do you agree? But he's kept inside the same class. Are you following me what I'm speaking? So the static method can be kept inside the same class, but he can't able to access the class member. It becomes like one of a parameter if I mention CLS. CLS is not a built-in attribute. Something like here, self is nothing but what? It's a class object which is being passed as an argument. Whereas here CLS becomes a normal argument. We can't able to access the members of the class. This attribute 1 can't be accessed at all. Attribute 1 can't be accessed. So converted to static method. Static means what? Standalone. Standalone method. Yes, standalone function, which doesn't require object initiation, but can't access the other members of the class. I am staying inside the class, but I can't take a privilege of accessing the other members of the class because I am standalone, I'm static. I'm a tea shop in a bank. I can't able to access the bank properties because bank is separate, tea shop is separate, but I am kept inside the bank premise. When the main gate is closed, I'm also closed. So to access this class, this method, you have to access the function, the class. Class.add, you have to access. Obviously, there is no doubt in that. You don't require a instantiation. Without creating the instance of the class, I can access the method. But the method, what I'm accessing, called add, which is a static method, means it does not have access to the attributes of the class. Only problem is I can't access the other members of the class. That is the only difference what I have between what? The static method and the class method. Class method can still access the members of the class, you see here. Static method cannot access the member variable of the class because it is standalone or static. Whereas class method says I can access the members of the class also. Members of the class also, be it a function or a variable, doesn't matter. But whereas the instance method says I can access all the members of the class or whatever, but the class has to be instantiated. Here it says I don't have to be instantiated. It can directly access using the class without getting an object creation. Here it says I can directly access the class, whatever the static method, without having this class instantiated, but This method can't access any other attribute of the class because it is a static method, standalone method. Now you see here the static method says what? Same way, you can create a static method and it says I can directly get accessed, but the only problem I have is you can't access this attribute. So 10 plus 20 is returning 30, whereas here on all 130 we are getting because we are getting the attribute accessed in the other types of functions and all. So you understood one thing here, guys. How many maybe decorators you have learned out of this total learning today? How many decorators you learned? 3 types of methods you learned, right? Abstract method used in the abstract class type and all. Static method, class method. Done. 3 decorators you have seen. And what is a decorator, you know? So today, I would say this concept of object-oriented programming is not implemented by us directly. It will be implemented by the framework developers or who were the application developers. But for the sake of understanding once for all, we are using this concept of understanding the maybe like what to say, the object-oriented programming concept. Take it in that way. Don't complicate. And I have kept all this object-oriented programming concept in this entire code base, which contains around 313 lines of code, or a lot of comments also there, blank lines are also there. Go through this to understand what the object-oriented programming concept entirely, what has been given here. This entire program has the object-oriented programming concept, what we discussed from today morning. 4.5 hours is not enough to discuss about the entire object-oriented programming concept, but we discussed by going a bit quickly. Fine, that is okay, right? Any doubts, case you are not able to understand any of this, or maybe like I would say the abstraction encapsulation, true, that is not always implemented. Maybe the encapsulation we may implement here and there, you can find in the program also. Abstraction very rarely applied, right? So we can see somewhere the abstract class might be created. Maybe very rarely you may see the abstract class is created or not. Maybe they did not create this abstract class anywhere. Abstract method. Nowhere in our framework the abstract method or abstract class is used. But encapsulation you can find somewhere in the program they may be using. This function is an encapsulated function. This function is of what type? Now you can say this function is what type of function? It is an encapsulated function using what access method? Access control protected. This is a protected method. And this is a class method. This is a protected method and it's a class method. In the encapsulation side, it is protected. In the type of function or a method type, it is a class method. So you can see in the context.py, we are finding these 2 concepts applied here. This get or create is a regular function. It's not a protected function. But we have other protected function, which uses the class parameter. These are all regular functions, not a class function, right? The regular function using self keyword. And maybe like you can say, this function is a protected function. Protected regular instance method, not a class method. But we have seen one class method. What is that? Something called what method we have seen here? The class method, which has protection also applied. Yeah, this one. Created for testing. So some testing related stuff they created, it seems. Created for testing. Class method they created, it seems. But there's a class method with the feature of protection they have applied here. Done, guys. So in the application development, they'll apply these concepts. At least they applied inheritance, they applied polymorphism, they applied, you can see polymorphism is applied by using args or k args and all, KWARGS and all they applied. They applied this polymorphism, overloading they applied. Sometimes they might have applied overriding also, right? You may see somewhere overriding is applied. You have seen that, you remember? Same function used in two different classes, but I overrided that old function. In between the Spark session and some other function, some other class, what the Spark session occurs, you have seen that as well. So all this object-oriented concept is implemented in a application development. Okay. Any questions, team? So we understood about these concepts. Okay. Within the given time, at least we are able to complete it by today. That is a great thing. So you know about in the object-oriented programming, class means what, object means what, right? Inheritance means what, methods means what, polymorphism, abstraction, encapsulation. Done, right? So you can go through this to understand some details about the instance method, class method, all this what we discussed. If you want to see a more detailed thing, if you want to go and dig into it and learn this Python thoroughly, means go and see here. In the instance method, I created a function without mentioning any decorator. No decorator is needed. Most commonly used, must have self parameter, can be accessed through object, the instance of the class, which is nothing but what? The instance method. Class method says what? I require a CLS as an argument. Need CLS parameter. Doesn't need self parameter. Rather, it needs CLS parameter. You need a decorator called class method. Can be directly accessed through the class. Don't need an instance of the class. But if you want to create an instance of the class and access also, you can do. Doesn't matter. But doesn't require an instance of the class. Class method. Static method says what? Decorator called static method is needed. No need of an instance creation. Directly can be accessed. But one thing is, no need of self parameter, no need of CLS parameter. Needed a decorator can access the variables passed as an argument. If you pass some argument to this function, it can be only used. Could not able to access the other members of the class. You can't able to access the other members of the class. These attributes of the class could not be accessed. By whom? By static method. Done. All this I have documented and uploaded in the G drive. It's all about making use of it. Maybe later we can see about the comparison between Python and Scala and all, something like that. But I uploaded all this in our G drive. Make use of it, guys. That's the only thing from my side, the ask. With me in this, I'll upload this entire code as well. Whatever we learned, right? I just uploaded some of the code yesterday. Maybe I can upload this code also to you. The fourth code what we discussed, or I can upload the entire code, but you should not get confused by looking into all this code. You got to go to the Python package core program where I have kept all our code, whatever we used so far. You can go and see, not today alone, later, even after an year, if you are going to work in Python, right? You are going into a company, you are going as a data engineer, but they are not using Python. You are using directly PySpark alone. I want to use Python, right? I'm getting a chance to use Python later only. I'm working only in Scoop. For example, yesterday, our team member was telling. Weekend or weekday, I don't remember. Okay, I'm working in my organization with, what to say, Scoop ingestion, right? Venkatesh was telling that. Scoop ingestion alone I'm using in my organization. Now only they are asking me to work in Spark, right? So you remember yesterday we were discussing. So that one, maybe like it depends. So you are going to get a chance to work on this program later. You can work on it, doesn't matter. But make use of this as a golden source, right? Nowhere you can see all these possible options and all to learn it easily, and the given option, only whatever is needed I have given. Not everything I'm giving here, okay? So I can remove all this, keep all of them like this, where you have to mainly concentrate on what? Mainly concentrate on the Python package core. We have all these programs. Or I'll keep this program separately. The important programs alone, what you have to go through, I'll keep it separately. These programs, at least you concentrate separately. I'm keeping it separately also for your reference. You should not miss. You should not say, Irfan, I tried finding where I could not able to find. You have to go here and see the core programs. Minimum these core programs you have to learn, especially the 4 core programs I provided. Done, guys. So I am in progress of, after we started working in Spark, I'm in progress of creating some quiz or test and all for covering Hive, Python and PySpark, these 3 alone. So by that, I'll make you guys learn, sit and learn and all by giving some time. I'll let you guys know when we are going to have the test or hackathon, or not hackathon, test and I mean like quiz and all. Get ready for that by spending some time of learning. Python, minimum you try to learn the core concepts at least. Okay, whatever you feel comfortable, try to learn. The fundamentals you try to learn. Exception handling, even you can leave, doesn't matter. Function-based programming, you try to learn at least that 5 concepts, not all the time. With me in this case, are you with me? Good. But we seen the Python programming language, whatever is maybe like needed for an application developer to the fundamental. Maybe I have one application developed, or I'm in progress of converting that into Python. Maybe Spark I have converted that and developed, and I'm just trying to get some time to complete that. Once I complete that, I'm just doing on and off and all. Once I complete that, I'll share you guys that particular program to you. Maybe I can create it as a recorded video and share you also. How in a banking application, you see here something like this. How in a banking application, or not in a, or you can consider like a banking IVR. In a banking application, an IVR call center. We are having all the concepts of the Python that we learned is implemented. Object, main function, inheritance, multi-level or whatever. The types of constructor. In Python, we use not primary auxiliary, we use some constructor called parameterized, non-parameterized, or whatever the, I mean like default constructor, closure concept, abstract class, overloading, overriding. Where we use what? Private member, when do we use? When do we apply encapsulation? All this concept, I created this program or this entire application in the form of functions and everything and modules in Scala program. Maybe I used to share that Scala program to the people, but let's go with the Python program for seeing the same thing. I can just record it and send it to you guys across. You can go through that. So you'll understand in a complete application development, how they implement all these concepts, what we learned. Clear what I'm speaking? Right? You can see this image and you can able to understand that concept, what I'm going to talk separately. As a Python based application, I'm going to convert this into a Python. I'm in progress of converting. We'll share you soon. Okay, guys. So I think we did not get a chance to start with Spark today. Next week, freshly, we can start that. So for that, we are going to start work on the core PySpark to a basic extent first. And then I'm going to take you guys immediately to the SQL PySpark or the PySpark SQL, which is very, very important. Okay. And which is our golden source, or which is our key thing to learn. If you learn this PySpark SQL, PySpark SQL, and if you go into the cloud platform and learn few components, 2-3 components of cloud, I can say a damn sure thing, or I can do what? Give an assurance, you can get the opportunities very easily. Whatever we learned so far is a huge effort, I know, but we are going to see the smart effort soon only. This huge effort should not affect that smart effort of you. Okay, keep that in your mind. Not everything is going to be like this. Programming language, as a programming language, you consider. Don't consider it like a regular thing that you are going to apply always. Okay, good, Vinod, you are counting it. Okay, I go countless, but we have to count as well, right? Obviously. However, yeah. So we'll start with Spark, right, from next week. And I wanted to, maybe basically what I do, I'll first cover the Spark core to a complete extent by spending a lot of time. I don't want to do that in our class. I want to cover the Spark core to a basic extent because Spark core is not directly used in the organizations by the people. RDD programming we don't do directly in our organization. That got ruled out. So, but however, how to work in RDD to a basic extent, I'll cover very quickly. And I don't want to cover this entirely for now. Maybe later, if time permits, we'll cover. But the fundamentals, what is caching, what is partitioning, these kind of concepts we still use. That I'll cover and take you guys to the Spark SQL directly. We'll work on Spark SQL data frame and all by spending some time in between. Then we'll go to the cloud platform and implement all of them. Okay, fine, guys. So any questions? Pawan, you can share your screen in the meantime. Any other questions, guys, you guys have? Anybody stuck anywhere in terms of implementing or installing this and all? Please let me know. Otherwise, have a good week ahead, guys. We'll meet next week. Yeah, go ahead. Whoever asks question or whatever, you can go ahead. But whoever, going to drop off, have a good weekend ahead, guys. Or week ahead, guys. Okay. Yeah. It was a hectic week for me, at least last week and all. And now we are into a better shape. Okay. We are trying to load some historical data just for 6 months, but the volume of data is in billions, even in trillions, actually. So we had some challenge in managing that. But ultimately, we were able to achieve in the last week. Almost yesterday, after the class, I was immediately going and switching on my laptop and see office laptop. I found the date was progress till March of this year. The data got loaded. Even the BigQuery is struggling. BigQuery in the sense like a Google platform, Google BigQuery we are using. BigQuery is struggling to process the data. That is where we found some challenges and we fixed them and all by adding some performance tuning on it. That and all we are going to learn. Okay, I'm going to show you guys all of them. Whatever at least I applied or whatever, okay, that we are going to see soon, which is a very interesting and very simple, not complex like what we are learning now. Okay, keep that in your mind. We'll progress further, guys. Okay, thank you all. Otherwise, we'll meet next week. Yeah, go ahead. Who is that? Who somebody is speaking?
Irfan, Piyush Irfan.
Yeah, Piyush.
From the abstraction side, I just want to reiterate my understanding. So using abstract method decorator, say in a father class, we have a function which is abstract method. And if it is getting inherited in some child class, means only the function name will be inherited, not the functionality. Means it will make the son class forcefully to re-implement or to define.
Exactly.
Okay.
Yes.
Okay.
See, if I have a father class with functionality applied, right, I will ask the child class to use either that functionality or override that existing functionality, not forcefully.
Yeah.
Not forcefully.
Yeah. Like
right?
in normal method.
Yeah. Normally, see, I have a function created. You want to use it or don't use.
Yeah.
But what I will do, I will say, hey, I bought a vacant land for you. I did not constructed anything. Construct as per your need. So I'm making it vacant, but you have to use that vacant land. Otherwise, it will always become vacant. It is unused. What is the meaning of then I buy a vacant land? That is the
means
abstraction
forcefully
concept.
You have to make use of it or re-implement it.
Yes. So in some design of a framework or whatever, right? Somewhere we need to use this abstract methods and all for implementing some forceful implementation. Otherwise, the literal example is this one, right? What we have seen. In a car manufacturer has to have some of the modules which has to be opened, which has to be kept open or kept unimplemented, which has to be implemented by the child class who is accessing it.
Okay.
Right? That must be implemented. So the abstraction says what? Some of the function which are all unimplemented in the parent class has to be implemented in the child class, which has to be controlled forcefully. Otherwise, you should not be allowed to incur that parent class even. All unimplemented methods of the parent class must be implemented by the child class if the parent class is an abstract class.
Okay.
Got it?
Okay. Yeah.
Got it?
Okay.
Yeah.
So this is similar like what we have learned earlier, like RDDs are like code abstraction. So it is hidden from us. So similarly, this is also hidden, but here
that
we
abstraction is a term that we use, right? Not always. Abstraction is a term that we use, but the implementation is abstracted for us. We don't have to worry about it. That is how the RDD says. Like you don't have to worry about how the data is taken and loaded into the memory like that and all, right? That is abstraction in general, the concept, right? But you can use it for forceful implementation or forceless implementation and all this and all. Like RDDs are abstracted. You are not going to do anything on that. That is how it has to be represented. Okay.
Okay, Irfan. And Irfan, regarding that first project, what we have been given, so I think most of us are able to complete till what we have learned, because there we are also using some
Yeah.
Phoenix and HBase and all.
Yeah.
So
That is
once
actually speaking nowadays, that is not a higher priority, right? The priority bit changes. Okay. So I wanted you guys to go towards, even I have one more project to share right away, but I did not share that because I don't want to dilute by saying, guys, do these two projects. Then when I give an important project, you will not be doing. Hey, already I did two projects, so I had to do the third project like that. You got my point? So I have something revamped and I'm going to give those things and all, right? Don't have to worry too much on the HBase Phoenix. Just try to know that later when we learn about Phoenix and HBase and all. Okay. For now, we can leave it as is. After we cover Spark, I'm going to give you a project in Spark. That is a comprehensive project. Have I ever shown that? How that looks like? No, right? So one
no, Irfan.
second, Pawan, right? You can see this is a comprehensive project which you feel very much comfortable or very much good in learning, right? Especially if you see this project. You see this project flow. This is a project what you guys may be doing it in Hive and whatever the other tools that we used, right? This project I used to usually share, but I did not share, I guess. But if you see this one, right? You see this one, this is entirely a modules that I created, right? To implement different concepts of using the Python with Hive and other components, PySpark with Hive and other components. You see here, this is the entire project you are going to do to achieve, right? By using the Spark, SQL, and so on, you're going to achieve an entire use case with all these connections made by creating everything as a functions in Spark, not in Python directly. The Spark level functions we are going to create to achieve all these use cases, identifying the intent of the customer, frustration score of the customer, most recurrent reason for the customer to contact the business, customer viewership pattern, profit and promo ratio calculation, or KPI indicators derivation, right? Demand indicator derivation, top end performing employees analysis, or status wise, maybe like aggregation that we are doing, order shipped after 5 days from the date of order placed. Like couple of things we are going to achieve as a future feature out of this project. Very, very interesting project, very important project as well. If you go through this project, or if you are in a position to do this project, I'm going to help you guys doing it. You can forget about rest of the other projects. This 1 or 2 projects are enough for you to fulfill your project requirement. Okay. I don't want to dilute that. That's the reason I did not given all those things and all. Maybe which one is more important and less important, we'll handle it. Okay. Don't worry. Some fleet project we are going to do as well. Right? This and all you guys are going to do to achieve some functionality. Not everything you have to know. Not everything you have to do. You take 1 or 2 of them and you are going to exhibit in your resume or whatever. Okay, that we can take care. That we will work on it. We have to bit progress towards that after completing Spark and entering into cloud. Okay, wait for it. Yeah, go ahead, Pawan. Pawan, please go ahead. You can share your screen, please. Yeah. So yesterday, after that command you applied, it is showing a different thing or what? Can you scroll up and show? One second. So what? Scheduler. So you added this, right? Display equal to
yes,
localhost :11. Job scheduler. No class definition found. So it's a kind of a Java issue, it seems.
Yes, sir.
Right. 1 second.
At first time while installing Python is not get installed, so that's why I shut down this VM, sir. After that again I from
No,
scratch
you
again
installed Python then? You installed Python?
only Python.
Yeah, you install that Python once again. I asked you to do that yesterday, right?
Yes,
Can you
sir.
run that Python program? No, go to the document.
One minute.
Can you type Java hyphen version in your VM? Java space hyphen version. Hyphen version, small v. Okay, then Python installation you have to check. Can you go and run that Python installation? What I have given in the document?
Yes.
No, it is not that. So don't go and do like this always. Go to the drive. I'll tell you. Download this document and keep it in your VM, right? Not this one. Wait. The 5.1, 5_1. Yeah. Download. Take it inside your VM and keep it in a folder like inceptez workouts or somewhere.
Yeah. Okay.
Today you may be remembering where you keep this file and all, right?
Yes, sir.
Tomorrow I'm going to remove this file, or some way accidentally it got removed. What you'll do?
Okay.
So you download and keep it with you. That is always better. You don't have to always go and search for this and all, right?
Okay, sir.
So that shows the importance you are giving for the learning, right? That is very important. Okay. Yeah. Go to the drive. Go to applications. Yeah. Open this home. Yeah. Fine. Go to IZ workouts. Install IZ workouts. Yeah. Paste it here. That's it. You have all the installation documents here.
Yeah.
You can download the 5.2, 5.3 and all. I'm going to share 5.3 and all soon. You are going to use. Okay. Open this. Yeah, you install this. Go and run this. All the 4 you can run even.
At a time.
Yeah. Wait. It will automatically take the.
Okay. Completed.
Okay. Can you type this one? Yeah. The latest version is installed. Okay. Type enter. Yeah. Type it. Type enter. Can you check now? PyCharm.sh ampersand. Just type PyCharm.sh. Don't type ampersand. PyCharm.sh. Enter. Okay. Can you do one thing? Did you download the PyCharm? No, right? Not yesterday. Okay. Can you go to the document once? Click on that in the down. Yeah. Can you copy this download, install and all, right? Come down a bit, I'll tell you. Yeah, copy that wget till the down, the last one. Yeah, up to here. Yes. Yeah, copy, put it in a
Yes.
notepad plus, put it in a gedit. Applications, go to applications in the menu. No, not here. Go to the menu, applications. Yeah. Accessories. There is a text editor, right? Yeah. Paste it here. Okay, go and make it as a single line. Okay, copy and run this from wget till the second line. Yeah. No, not all of them. Till the second, the first one. Yeah, up to W. Guys, whoever wanted to drop, you guys can drop off if you don't have anything. Don't have to stay. Maybe if you're interested, you can stay. Otherwise, not needed.
Yeah, it's fun. This is Ram here.
Yeah,
I want to know in G Drive where can I find that the coding and all? You said something all code.
Python code and all. See, I will tell you how the G drive will be looking like. Okay, I'm taking your screen share, Pawan. Wait for a while.
Okay, sir.
See, if you see here,
Can I share my screen?
1 second.
I already opened my G Drive and all. Yeah.
No problem. Let just see here, right?
Yeah.
See, we have over here. This is the drive. Okay.
Okay. Yeah.
This is the WDWE, WD 2023, right?
Okay. Yeah.
In this drive, you can find folders are created, right, for every topics.
Yeah.
Forget about these 4 topics.
Okay.
Just go to here, Python PySpark.
Okay.
Double click on this. You can find all the documents required. What are the documents we have? I shared Python installation document, Python workouts document, some hands-on document and all I opened here, right?
Yeah. Correct.
This document is kept over here. Okay.
Okay.
And apart from that, whatever the theory that I'm taking, maybe I'm going to delete this Python PySpark W41 and I'm going to save this file. Python PySpark W41 because I scribbled something on this, right? I'm going to save this and I'm going to keep it here by the end of the day. You can see here I uploaded this.
Okay.
So you can download the PDF, PPT what I'm using in the class here. This is for Spark actually. Spark PPT I have as well. Spark PPT will open from next week onwards.
Yeah. Okay.
Right. And then Python scenarios I have given to the people for working on all the use cases that I have given.
Okay.
Right. Like this.
Okay.
You can see. This one you have to work by spending your free time and all to get a grip on the Python programming. Okay. Apart from that, all code I have kept for the weekday 30 and weekend 41. If you are interested in looking into weekday 30 code also, you can look into it. Okay. But first of all, you go to your weekend 41 group, 41 folder, and all the code what I had here. I missed to say one thing to the people. I'm not sure whether they know it or not. I copied all this code from here and placed it over here. What all they have to do is they have to just copy all this code, download, and take it into their platform and paste it here. By right-clicking on this project, they can paste the entire code, what they're copying in their machine. See, my code, what I developed here, or the classroom code, what we developed together, I kept it over here. In the core, in the Python package core, we have all the programs available. Got it?
Yeah, got it. Yeah.
It's all about, this is the code we worked. Especially the code, if you see, function-based programming _3 is the complete function-based programming what we learned.
Yeah.
You see here, you will have the entire program, what we discussed about function-based programming, all the concepts, whatever, some real-life scenario or whatever, arbitrary argument, global function or higher order functions, right? Or closure, all the concepts, built-in functions, predefined functions, or lambda functions, anonymous function. You remember? Lot of things we discussed. All these are kept over here, including the recursive function, Fibonacci series, or whatever we discussed, right?
Yes.
So this one has the entire core programs what we learned. This one has exception handling programs, and this one has the object-oriented programming what we learned today. I uploaded up to date whatever we learned today till the last we concluded, right?
Yes.
Instance method means what? All this and all. I kept it over here.
Yes. Okay. Yeah.
Got it?
Yeah. Got it.
Yeah.
Yes.
This is how we access the code base. Okay.
Yeah. Okay.
Right.
Thanks.
Yeah. Go ahead, Pawan. Can you share your screen? Okay. You got this software downloaded. Just type enter. Enter. Yeah. Go to your document or on notepad. Yeah. Go to the second line. Yeah. Wait. Just go and keep your cursor after 998. Yeah. Put a delete button once and give a space. No, not that delete. It is backspace. You have to use a delete button. Okay. Use the backspace from here. Yes. Okay. Now you copy that second line. Second line completely. Yeah. Click on it 3 times. Double click plus one more click. Yeah. Right? Yeah. Take it inside. Paste it. So downloading some software from the internet, renaming that software. Okay. Yeah. Now go back to the notepad. Yeah. Do the rest. Wait. Sudo rm-r. Can you give like this? Sudo rm-r. Go there. Go to the document. To the notepad. Sorry. To the terminal. rm-r. Sudo. Yeah. Sudo rm space -r. rm space -r. Yeah. Space usr/usr/local /usr/local /python. Not Python. PySpark. Sorry. PyCharm. Okay. Before that, you remove that USR. One USR you are given. Type Control C. Yeah. Put up arrow. Go and remove that USR. Yeah. Put a slash before the USR. Type enter. Type HD user. Check for the case sensitivity. Yeah. Okay. Done. Now you go to the document, that notepad. Copy the rest of the lines.
All from tar.
Tar XVCF onwards you copy. Tar XVCF till the last line. Yeah. Execute. 1 second. Okay, can you open that VI before this, right? Just open VI, type VI, delete this line and type VI space that home HD user /home /HD user /dot bash rc .bash/rc dot. You have above, right? 3 lines above that content. Yeah.
Yes.
Type this. Yeah. RC. Just type RC. Fine. It's okay. Yeah. Type enter. Can you scroll up to the top line? Can you put escape WD double D DD 1 second. Can you scroll down a bit and comment that 1, 2, 3, 4, 5, 6, 7th line. 7th, no, go above. Yeah. Can you come down? 1, 2, 3, 4, 5, 6, 7.
Yes,
Yeah.
sir.
Put insert type I. Yeah. Hash. Put hash. Yeah. Save. Control :WQ. Escape :WQ. :WQ. Shift : WQ. Escape. Shift :
Yes, sir.
WQ. Not this one. WQ. Escape : WQ. Yeah. Enter. Now, can you run that pycharm.sh ampersand? Just type. pycharm.sh ampersand. Enter.
And graphic is gone, and this.
That is a process ID.
Okay.
Still getting that error again?
Again, sir. Java graphic environment.
Not initialize graphic. Okay, 1 second.
Okay.
Can you type enter? Enter.
Type.
Just enter.
Sir, I have typed, but it's not getting.
Okay. Control C. Just type enter. Yeah. Put unset. Type unset capital display space capital display. DISPLAY display. In capital case. Yeah. Type enter. Can you run it again? pycharm.sh. Yeah.
Again, it's showing the same.
1 second. Yeah. or type like this: export space display, type enter. Yeah, yes, export space display, capital display equal to :0.
Enter.
Yeah. Now you try running it again.
The setup startup error has been gone and again the code is same.
Let's see. Wait for a while.
Okay.
Yeah, it is opening PyCharm, right? So
Yeah,
take a note of this. Or you do one thing. You go and paste this, that export Py display equal to :0 and all in your this thing. Like can you open a new terminal? I'll tell you. Going forward. Yeah, new tab you can type here. Go and give vi.bash.rc. vi.bash.rc space .bash.rc. Yeah. .bash.rc without dot in the second dot. Just RC. Yeah. Open. Oh, it's not coming. Can you type escape :q? Oh, you are in the install folder. Okay. Okay. Yeah. cd dot dot. Then you type cd space dot dot. cd space dot dot. Yeah. Type enter. Now you give vi bash rc. Type enter. Type enter. Just enter. Yeah. Put up arrow once, twice. Open. Maybe go to the first line. Yeah. Come down a bit. Before that RM, you commented right one line. Yeah. Yeah. Type I. Enter. Enter. Up arrow go. Yeah. Type that whatever the commands that we used, right? Go to that other terminal. Display. You set unset display. Unset display. Unset small case. Display capital case. Yeah. Space. Yeah. Go to the next line. Enter. Yeah. Go to the dock with that other terminal. Click on that other terminal. In the left side is there. No. Wait. Don't close. Yeah. Go to that other tab, first tab. You see in that left side one more tab. Yeah. Click on that. So export display equal to :0, right? Yeah. Type there. Copy this and paste also. Not here. In the V editor. Export display equal to :0. Capital display equal to :0. Check that. Do we have the same over there in that other tab? Yeah, equal to :0. Correct. Go there. Go back to the dock, that other terminal. Type escape :wq. Yeah, come out. Now you open a new terminal. Yeah, wait for it. Go to that other PyCharm in the down. Yeah, click on that. You can go and create a new project. Click on new project. You know from here how to do?
No, sir.
Just try to, okay, wait. Just give new project and base interpreter. It has to show the Python interpreter. Can you click on the Python interpreter? No. Down arrow is there. Base interpreter. Cancel this.
Yes, sir.
Click on that base interpreter. Yeah, click on that.
Not showing.
Oh. You have some problem in the Python, it seems. Okay, go and okay, you can't do that. Somewhere the Python is not installed properly for you, it seems.
We have installed, no sir, now only.
No, it is not fully installed. In the sense, it is saying like already installed, but it is not installed. Because of some issue you had earlier, I'm not sure.
Yeah, yes, sir. Before that, I came up to this step, and PyCharm is not getting installed. Python is not getting installed, and so that I have quitted this new project, sir.
Okay, no problem. Wait for a while.
Okay.
So just type this, try this once quickly. We'll see.
Yes, sir.
RM-RF -RF USR local Python USR bin Python /USR/bin Python. Always you have to put slash. Okay.
Okay, sir.
Star Python star you have to give. Okay. Put slash before. Put Python star. Enter. Sudo you give before. Put up arrow. Go to the first character. Type sudo space. No. No, sudo have to come first.
Before RM.
Yes. Space. Yeah. Type enter. HD user. Yeah. Now can you give that installation command once again? Python installation. Wait. Close this, cancel this, and close this. Close that other window, that PyCharm window.
This one, sir.
Yeah. Close it. Cancel it or close it. Okay. Can you go back to the document, to that notepad? Wait. Go to the PDF. PDF. Yeah. Go to the first point. First one. No, not this one. Number one. Go above. Yeah. One second.
Okay,
So
sir.
run that. Run the first three commands. First three lines. Yeah. Copy and paste all of it. Yeah. Yeah. Run it. Type enter.
Unable to execute.
How the directory is lost? 1 second.
That means we are
Sorry.
doing in another terminal now, sir. That's why.
Which terminal? No, that is okay.
Okay.
Python all are removed. Bin. Can you go to cd/bin? Space /bin. Yeah. Type enter. Enter. ls. Just enter. LSYUM. That is there. Okay. I think. Okay. Fine. Should not be a problem. Echo $path. Can you give echo dollar capital path? Dollar capital path. Enter. Okay. Can you give that yum install and all now again? Can you try that?
Which
Can you
one,
go to
sir?
the document? Can you go to that document PDF, please?
Yes, sir.
Yeah. Run that second command. Enter. Okay. Can you put up arrow? Can you put up arrow? Remove that first echo hyphen E and done. Yeah, all this up to sudo, up to sudo, up to sudo. And remove that hyphen S also. Wait. And type dot before the M, you type dot before M. Yeah, dot slash M. Dot slash before, not after. Before M, type dot slash YUM, before YUM. M. Yeah, dot slash. No, without giving space. Yeah, type enter. LSM, just type LSM. Not M. Okay, fine. Go back to that first tab. Yeah, run that command. Type enter. Yeah, copy and paste that commands from the PDF.
From this all, sir.
Yeah. Delete this, remove this. Actually, family is waiting for the lunch. They keep calling. We'll do one thing. I think like this M is last, right? We'll try to get it recreated. Okay, we'll do one thing. We will connect maybe sometime later also this week. Okay. Let me know. We'll connect as well. Okay.
Okay, sir.
Requires some time to fix. Okay. Yeah. Fine point. Yeah.
Thank you, sir.
Thank you.
Okay.
Bye.